you have any questions in regarding to the day 1 and day 2? I see few people have emailed me. I couldn't respond to them. I will try to, if you can share your question over here, I can try to respond them. Or in one-on-one session also we can discuss. Okay. So let us wait for a couple of minutes. We can start from 3:02 p.m. 3:02 p.m. Okay, so let's start. Yeah, Padmapriya, you have a question? Yeah.
Sir, I have a question from yesterday's session. Shall I
Mhm.
ask now or?
Yeah, go ahead.
Yeah, I I have closed that window in my screen.
Okay,
But I had a question on that integration. I was not getting that.
okay.
Yeah, later on, if possible, I'll open my screen and share it
No
in.
problem. Yeah, should not
Yeah,
be a problem.
thank you.
Okay, that's good. So let us start our session. I'll share my screen. Okay, I think it's taking some time to load. Yeah, so yesterday, as we have discussed, we talked about two different cuts of a propagating medium. One being a horizontal cut, which is also known as the longitudinal cut along the propagation direction, and another cut is a vertical cut, which is across the propagation direction, normal to the propagation of direction, uh, propagation direction. Okay, so it's still taking some time to load. Yeah, it's still taking some more time to load. Yeah, yeah. So we discussed about this longitudinal cut yesterday. Today we talk about the transverse cut because this part was remaining from yesterday's discussion. So we'll make a cut which is kind of a transverse and try to see what are the different modes that may exist. Okay, so a quick raise of hands of how many people will be doing along with me. It will help me to understand. Okay, that's good. So I think a good number of people are doing along with me. That's great to know. So let us go to the COMSOL file again, and we go to the file new, and then go to the model wizard. And over here, as you see over here, it's a cross section of the 3D geometry. So it would be a 2D cross section. So we are again going to make a 2D geometry over here. Okay, so let us go to 2D. Okay, and here we need to go to optics, wave optics, and choose again electromagnetic waves frequency domain. Okay, this is again the same physics we are going to use. Okay, okay, so select this and click on add, and then click on study. Okay, and here there is this difference over here. So here we need to use the mode analysis now. It is the mode analysis that we're going to use. So you can just select this mode analysis and click on done. I will wait for a few seconds for you guys to add this. Okay, so I hope you have added the mode analysis and click on done. So this is what you will see once you complete that model wizard. And the next thing is to make a geometry which is very much similar to this one. Okay, a circular cross section. So again, the thing we need to do is that we need to change the units of geometry length unit to micrometers, as we have been doing till now. The length unit you need to change from meters to micrometers. Okay, and then we need to create two concentric circles. So just right click on my geometry and click circle, and you can make a circle with a radius of 8 micrometers. This is a diameter of 16, radius of 8. Okay, it's positioned with the base as center. So the circle origin is at 0, 0. Okay, and we need to make one more circle with a radius of 40. Okay, so we'll turn, and then don't forget to click on zoom extents or go to 3D with zoom extents. So then you can actually see the both of the concentric circles. Inner is having a radius of 8 micrometers, and outer has radius of 40 micrometers. Okay, I'll wait for a few seconds for you guys to add both of this geometry.
So there's some issue. I do not know why is it happening, but in circle one, we have radius 40, sector angle 360 degree, right?
Okay, okay.
And in circle two, we have radius 8, sector angle 360. No?
Yeah, yeah, both are same
Same.
sector angle.
So I build all the objects, but one circle is showing, the other is not.
You need to click on zoom extents.
Zoom extents. Oh yeah. Okay. Fine. Got it. Yeah. Thank you, sir.
Mhm. How about others? Are you able to get this both the circles?
Hello, sir. Chetan here. I have a small
Uh,
question.
Yes.
yeah, yeah.
Sir, the version of COMSOL that I am using, how do I get the option of just the boundary and not showing the area? As in, the circles I'm getting are concentric, but they are completely filled circles, not just the outer.
That's
I think
that's
in
not a
lecture
problem. So
one,
once,
yeah.
yeah, no, if you go to
Yeah. For me
form,
also showing the
yeah,
same.
no, no, that's not a problem. Once you go to form union build all, you'll get
Mhm.
that filled structures. Don't
Okay,
worry
okay,
about that. Yeah, it's actually a filled structure, a solid structure actually. So if you
okay,
make it curve, then it becomes curve. But unless until you
Okay.
make it keep it solid, it's solid.
Okay.
okay.
Okay, cool. So next is the material section. Okay, I hope you are able to add both of these geometry. Any questions or doubt till now? Okay, looks good. So I hope you are able to add both of these materials. Now we need to assign the
So I have a doubt.
Mm-hmm. Yeah.
Oh, actually, it's in gray color inside for you, right?
Okay.
Circle.
Mm-hmm.
For me, it is not like that.
Which color is it?
Actually, it's empty.
So you can go to form union and click on
Okay.
build all. You will see it as a gray color. It's not a problem.
Yeah,
You
sir. Yeah, yeah.
important thing is that you should be able to assign the materials to the whole domain. Okay.
Yeah, okay.
Yeah.
Got it now.
Okay.
Thank you.
So just yeah, looks good. So next is to right click on the materials and apply blank material because we're going to apply a blank material to all of them. Okay. So just right click on material, blank material, and you can just so you can just deselect the central domain. So you apply the for the cladding only. Okay, so just write clad over here and give the refractive index of give it as 1.4378. Okay, so you need to give the real part refractive index of the clad as
Uttam,
1.4378. Yeah.
Uttam, how? My name is Faraz. Sorry for
Mhm.
interrupting you. How to deselect the inner circle? Could you please show
Yeah,
it?
you just need to left click on that domain. Okay, so it will go away. If you click left click once, it will select. If you click again, it will deselect. Like that, it will happen.
So I have to select the outer. If I want to just select the outer one, then I
Yeah,
have
so
to
by
click on
default,
the.
both the domain would be selected by default. So you need to
Okay,
deselect the central domain.
okay, okay.
Hmm. Okay, that's good. So I've given the real part of the refractive index of the cladding as 1.4378. Okay, I hope you are able to add that material property.
Sir, I'm
Hmm.
not able to edit that unit, the
Unit you don't
value.
need to change, only the
Uh,
value you need to change.
Sir, actually, we used to choose material whatever we want, right? Like
Uh-huh.
yesterday, you were telling that we can just we can just give a name and we can change the refractive index here.
Yeah, yeah, that's
So
what we
for
are
that,
doing,
we are
right?
choosing that clad, right? But I'm not getting that in my screen.
Okay, so did you right click on material, add a blank material?
Yes, I have done.
Yeah, so then you uh, select this domain.
Yes, I deselected it, the
So right,
central one.
so you
Yeah.
have one over here, mentioning one over here.
Yes, sir, I have.
Oh, so these values you are unable to mention. Nothing is coming over here. Material contents.
Yeah, it's coming. Okay, I'm
Come.
adding now
Okay, okay,
value.
that's good. Okay, that's good. So the real part you need to mention is 1.4378, and similarly you can again add one more material, blank material, apply to the core, and then you can give it as 1. 4457. Okay, so here you can, instead of material 2, you can write as core. So cladding and core.
So what is the refractive index value for core?
Yeah, I will just mention in the group chat as well. So I mentioned it over here is 1.4457. So a little bit more than the cladding. Okay. So both of them are still lossless. So if you want to calculate the attenuation coefficient, it will be 0. So accordingly, based on the specification sheet that you have for optical fiber, on the value of K, you can put over here and then also find the attenuation coefficient. It could be in order of dB per kilometer. So you can then calculate how much losses will happen for a 1 kilometer long optical fiber in losses in dB. Okay, that you will get to know once you are able to do mode analysis. Okay. So are you guys with me? Are you able to add these materials?
Yes, sir.
Uttam, just I need just one minute. Could you please share your screen? Yeah.
Yeah,
I would like to that you added in the materials. You have to add two times, one for the clad and one for the core, right?
correct.
Okay, and then we can add it. Okay,
Mm-hmm.
okay, 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 and okay. Understood. Thank you.
Mm-hmm. Okay, looks good. Any more doubts? Any more questions? If anyone is stuck somewhere, okay, looks good. Okay, so next, you can see that wave equation again. The material model is same refractive index, no change required over here. PEC has been applied to the outer boundary, so we assume that all the modes that may exist may die down before it reaches the edge of the cladding, and the initial values are 0. So no boundary conditions are required over here. No source conditions are required in mode analysis. Okay. Next is important part of mesh. Okay, so the mesh, uh, you do not need to do this control mesh in this case, because the modes that I will show you in some time, it's not a function of the wavelength. We are not modeling the propagation, and that is why you can actually disable this frequency control mesh, that is a physics control mesh, and click on build all. So this kind of mesh is also would be able to resolve the modes of propagation. Important is that we are not modeling the propagation. Okay, so we are only modeling the modes that may exist, and that modes we can actually resolve using the normal mesh. You don't need to have physics control mesh. You can go ahead and do the physics control mesh actually, but the only problem that you will face is that it will be uh, too time consuming, especially for finding so many modes. It will be very difficult to solve it, especially if you don't need it, then why you want to do it, right?
Uttam, just correct me if I'm wrong. We are here just checking which kind of modes exist in our simulation model, right?
Yes. Okay, so I hope you have gone to the mesh and disabled this
So,
physics control mesh.
so when exactly do we need this? I'm Sudha here. And
Hmm.
electromagnetic waves and frequency domain. So when in what scenario? So if we are, let's say, doing polarization maintaining fiber or a multimode fiber, right? So in which case is it necessary to enable this contributor?
This physics control mesh,
Yes. Yes.
yeah. Then when we are planning to model the propagation
Okay.
across a medium, so whenever we are trying to do this propagation, then we
Mm-hmm.
need to use this physics control mesh. So whatever problem that we have worked till now, it always involved propagation of electromagnetic wave, if you remember, right?
Mm-hmm.
So all the cases the electromagnetic wave was propagating. We are not dealing with any modes. Only the modes that we found were boundary mode analysis over here,
Mm-hmm.
just at the edge of them, right? So at those places, you actually don't need to do a physics control mesh.
All right.
Yeah, once you see the mode, then you will understand. It's like intuitive. Yeah.
All right. Thanks.
Okay. Any more questions?
Sir, I am Gauri. I have one doubt.
Uh-huh.
Sir, in this, we are using that physics. We are using that physics now, sir, like electromagnetic wave frequency domain. In this, if I extend means I'm having some equation, component formulation. Those things are there
Yeah, it's
for
just
what?
for your understanding that what equations it is solving for. It's actually solving for wave equation. What kind of components are you solving for? So three components means all the x, y, z components. That's by default. But if you want to only solve for in plane variables, for example, ex and ey, then you can also choose in plane vectors. Sometimes you only solve for out of plane vectors, the ez components. Then you go for out of plane vector. But the most easiest way to work is three component vector. Sometimes you don't want to work with out of plane, you only want to work with the in plane, right? So in specific modes you're working with tm modes, right? So those are the things. So and formulation is what will come in some time. So right now we are still working with full field. The next we'll talk about scattered field. So scattered field is specifically for calculating the scattering of an electromagnetic wave propagation, and if there are any obstacles in between, then there would be some kind of scattering, right? So that we will do in some time.
And the other one was equation form is steady control, and there is so much option.
Yeah. So you keep it by default everything. Don't change anything.
Okay.
Okay. So you keep it the same whatever it is. Study control means is whatever in the study, the same equation is being going to build. Okay.
Okay.
So you don't need to worry about it. So yeah. Okay, looks good. Any more questions?
Sir, I have a
Uh,
question.
Yeah, sorry.
Yeah, yes, sir, I'm Chetan here. So,
Mm-hmm.
sir, I wanted to ask this question yesterday itself, but it was too long, I felt, so I'll just put it today. Uh,
Mm-hmm.
I'm basically very new to optics domain, so I just wanted to understand when we say modes of propagation or just modes, and also when we yesterday we talked about something called as effective refractive index, and
Okay.
then terminology stating that according to the effective refractive index, you have a particular mode coming up. So I just wanted to understand the differentiation between what do you mean by an effective refractive index, number one, and number two, what do you mean by a mode of an electromagnetic wave? And when we say different modes exist, what do we actually mean by that? Because you change refractive index and you say, according to this refractive index, this mode will exist, and according to this refractive index, these modes will exist. So I just wanted to understand or help me in visualizing what exactly that is.
Yeah, I understand.
Yeah.
That's actually a fundamental question. But if I keep, if I start talking on that, it'll take even half an hour to explain. So I will try to be concise on explaining the thing. So basically,
Okay.
if you have the any optical uh, optical dielectric media, when
Mm-hmm.
you are applying an light source, okay, the light source is nothing but electromagnetic fields. Okay, so in we can just instead of electromagnetic field, let us focus on electrical fields. Okay, so
Mm-hmm.
so if you see this kind of fields that I'm drawing over here, so these are
Yes.
the electrical field directions. Okay, so these are the
Mm-hmm.
fundamental modes,
Mm-hmm.
orthogonal modes actually. These are like so there are a few fundamental modes where the coupling of light would be the highest. The propagation of those particular modes means the electrical field which is oriented in a particular direction. All this electrical field is oriented in a particular direction, and this is the
Mm-hmm.
orthogonal mode. So if you're able to propagate this particular mode, then the light would be propagating through this dielectric media with the lowest losses. Okay, but it happens so that we also have higher order modes, whether we want it or sometime because of the obstructions there could be some mode conversions which we sometimes we want it as well. So right, so these are the higher order modes that I've drawn. It's outwards and inwards, they're circular. So that's all
Mm-hmm.
based on the direction of electrical fields.
Mm-hmm.
Okay, and effective refractive index is it's a kind of mathematical terminology. It's not something like a kind of physical thing, yeah, because we are dealing with mathematics, right? So
Mm-hmm.
based on the refractive index of the core and the cladding, an effective refractive index actually correlates with a specific mode. Okay, so
Mm-hmm.
effective refractive index of this particular mode would be different as compared to this one. Okay,
Okay.
so these both are kind of a degenerate mode. Degenerate mode means they are both kind of same mode, but they are kind of orthogonal, so like almost kind of similar modes. So
Mm-hmm.
um, so each of the mode will have its associated, or they tie up with a particular effective refractive index. Okay,
Okay,
so the
sure.
effective refractive index will change based on the material properties again over here, right? So but
Okay.
the mode will remain the same, right?
Okay.
So just the value of effective refractive index will change, but the mode, the fundamental mode will always remain the same. Higher order modes also will remain the same, yeah. But the value of the effective refractive index will change based on the value of this optical fiber.
Okay.
And sir, would you suggest anything like as I don't remember the name of somebody who's asking this question. So I'm also very new to optics, and I would
Okay,
want
it's Chetan. Yeah,
so that yeah,
yeah.
yeah. So I would want that apart from doing all this simulation, I should have better understanding of what you're teaching. So that we have an effective understanding of what we are doing and what is the logic. Like yesterday, somebody asked so many questions, and I was sometimes lost in between because I didn't
Hmm.
know that much about optics. So would you
Yeah.
recommend or suggest any parallel course, any fundamental reading or some book or textbook so that we have a basic understanding of what all you'll be taking for the next 2 3 days?
Mm, yeah, I mean, actually I think the good part of this course itself is like we have people from both beginner as well as experienced, intermediate and experienced level, yeah, of especially with knowledge of using optics. Um, so just don't get overwhelmed. Means I won't recommend to go for any other course within these 5 days. You might not have much time to deal with those things. So uh, yeah, so because this optics course itself is like huge, so every day I'm going to cover some different topic. Like for example, today we'll talk about scattering, which is completely different than what we did in the second day. But in that overnight period in the morning session, I don't know how much you can learn in 2 3 hours, because it's completely new topic that we'll do. For tomorrow also we do something like multiphysics analysis. So that how can I don't know any references there for multiphysics
Uh,
analysis.
Yeah,
uh,
so actually, my concern is the reason of me joining this course was because
mhm,
I am actually working on some terahertz based filter devices for using
okay.
metamaterials.
Hmm.
And I would mostly be working in the fabrication lab, but to have a better understanding of how things are working inside, that's
Hmm.
why I wanted to learn COMSOL.
Hmm.
So now, would you recommend or suggest like how should I better uh, integrate both of these, like understanding the things, doing on simulation and working in the fabrication because my background is electronics.
Hmm. Yeah, I understand this learning curve would be definitely steep, especially if you're diving now. It will take like 6 months to 1 year to understand the optics part. So are you using fabrication in optics like silicon photonics, or how is it?
Yeah, using so we are using silicon wafer and on top we are making we are doing some depositions and
Okay. Hmm.
gold gold
Okay.
deposition.
Yeah, so the similar to that, scattering. When we talk about scattering, that is what would be the more important thing. For you have a air and substrate, silicon substrate, and then you can deposit a gold nanoparticle or gold layer and see how much the scattering going to happen. What is the change in transmittance, reflectance? All
Yeah,
those things would
exactly. The
happen. Yeah.
transmitter curves I would
Mhm.
be focusing
Yeah,
on
yeah,
only
yeah. So
because
that's what
it's
we
a
are going
filter.
next. Yeah, but we are going
Okay,
next.
sure,
Actually, this is what we are
sure, sir.
going next. Yeah, yeah. But the physics part. Um, Again, it's kind of huge things what we are doing, and every day we are doing different. So but yeah, if you're interested, you can always go, um, what you can refer, because yeah, it's very difficult to challenge to tell, because for example tomorrow just 2 days are remaining, and tomorrow we go for physics control, this multiphysics node, and last day is ray optics. So if one book if I would suggest is Salah and Tech. I don't know if you have seen that books, the photonics book.
Oh, that's his basics, physics. Yeah,
Yeah,
photonics
yeah.
and
So it talks
Saleh
about
and Aish.
the basic ray optics as well.
Okay,
So yeah, that would be a good fundamental thing to start with. Even it talks about the modes as well. Yeah,
okay, sir.
Salah and Tech fundamental of photonics. So that is good. Then Eugene Hedge would be another good option to start with. But yeah, so you can just choose on what topics we are working and then focus on those particular chapters.
Sure. Thank you.
Okay, that's good. Cool. So the next step that we need to do is mode analysis, and in mode analysis, we need to change our operating wavelength, which is around
Excuse me, sir.
1.5. Yeah,
Sir, actually, I'm facing issue with the mesh. It's coming out as a black screen.
yeah. So you just need to disable
Black
this.
there.
No, no. Can you have you disabled this electromagnetic waves frequency domain? Physics control mesh. Have you
No,
disabled it?
no, sir. No, 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 no.
Yeah. Because if you are enabling and doing, the reason why you're getting black is that there's so many mesh elements actually, so it becomes
Now
black
it
in your
came,
system.
sir.
Yeah.
Yeah, it,
So
it
the next
came
thing.
now. Thank you, sir.
Yeah. So next thing you need to go to the mode analysis, and you need to change the frequency over here, the wavelength over here to 1.55 micrometers. Okay, and enable the number of modes. You can search till 6, maybe 10 modes. Let us search with, and then search for modes around shift. So in that you need to mention whatever you mention in the core. Okay, so I'll wait for few moments for you guys to add this or update this mode analysis setting.
Sir, can you repeat it once?
Yeah. So basically what I changed over here, the first thing is the wavelength. So I've changed from 1 micrometer to 1.55 micrometer, means we are working with 1550 nanometers of light source. And then desired number of modes. So how many modes I want to search for? I want to search for around 10 number of modes. Okay. And search for modes around. What are the values of modes around that I can search? It's around 1.4457. Okay,
Yes.
is it fine? Looks good. So just
Yes.
click on compute
Yes.
and let us see if you are able to get some results. Just make sure you have disabled the physics control mesh, otherwise your system will get hanged. And I'm not sure if you're able to join the session again.
Excuse me, sir.
Yeah.
We have to search the mode around the 1.4457, right?
Yes.
I'm using 6 version and it has
You
some
can use 10 modes. It should be good.
10
High
modes.
number of modes you can search and we can figure
I,
out actually.
I'm not able to give significant figures are less here. Up to 1.44 it is accepted.
1.44 only.
Yes.
Which version of COMSOL are you using?
6.
Ah, but it should. It's just not able to. Can you share your screen? Perhaps I can just take a look. Are you sharing?
Yes.
Okay. Yeah, actually, you may be able to add, but can you close that add material section? No, no, on the right hand side. Actually, on the right hand side, add material section is there on the right hand side. So, okay. Can you just pull it towards the right hand side, the settings? So maybe you can add it, but you're unable to put it. That one, can you just pull it? Actually, can you put something like 5.7? It's not taking inside.
Yes, I seems to be
Maybe,
not taking.
yeah. So instead of one, can you write 15? Just 1 5. Is it taking something else also?
Okay, like medicine
Yeah.
instead of
Yeah. Maybe we cannot see it. Perhaps I don't know. If you take it, I don't know.
probably it
You
might
know.
be taking.
Uh, I cannot see it. Perhaps. Yeah. Any other people facing the same issue? Anyone know? Okay. No problem. So
Just the
that's good.
screen aspect ratio thing, right?
Yeah, I think this that if you increase that width of the settings pane, I think maybe you would be able to
So
see it.
reduce the model builder because then you can. Yeah,
Ah,
Okay,
yeah,
yeah,
sir.
yeah, that's
I
good. Yeah,
understand.
yeah, yeah.
Okay. Sorry.
That's good. Okay, so anyone getting the results? That's good.
Yes.
Okay, that's good. So I think people are getting the results.
Yeah.
But what you see from here is not that important thing actually. You are unable to see the modes perhaps specifically. So if you want to see the modes, you need to plot the electrical fields as I was discussing with Chetan. You need to see the electrical fields. Okay, so the first thing is to see the power flow. So just change the expression to know the power flow. So you can see the power flow in z direction, means out of plane. So that is the variable name power. If you search for in replace expression, ewft.povz. Okay, so you can see the power flow, how the power flow is happening. That is the most important uh, way of understanding the flow within this optical fiber. Okay, I will just share this also. This share it in you in this.
Sure.
Okay, and
Uttam,
yeah,
Uttam, I'm getting the results, but the image of this plot is different, a bit
yeah,
different
yeah.
as
Don't
compared to
worry.
yours.
Yeah, don't worry. That will get to it. So now what you can do, just change into the power. Okay, expression as power that I'm shared in the message box, and then electric field. You can go over here and then just see the lowest mode over here, and just click on plot. So you can see that the complete energy is located in the center of the core, right? So that is the fundamental mode. It seems to be a fundamental mode. So we'll see exactly whether it will be fundamental mode or not. So first so here you can see that both of them are like the same thing. So you will not be able to see any difference between them. So it looks to be the same fundamental mode, just orthogonal mode. Okay, and then you can just play around with those. You will see that there will be some change in the other higher order. These are all other higher order modes, but you cannot see the which exactly mode is it, which hybrid mode is it exactly, right? So are you guys able to get this modes, fundamental mode? A quick raise of
Uh,
hands.
uh, Uttam,
No, sir.
Sir,
Yeah, sorry. Yeah,
sir, where did you change this expression?
expression surface one. If you just open this over here, go into surface one, and you need to change the expression as povz. Okay.
Okay, sir. Okay,
Yeah.
sir.
So this is, if you just search for the power, you will get that variable. Okay.
So, is it like, do we have, like, how do we play with the different modes? Like, you have a lot of arrows in your plot
Yeah, yeah.
next to the plot. I don't see it on my actually, and
Arrows.
I
I
feel
don't
it
have
will be.
any arrows. Which arrows are you talking about?
So, uh, I mean, going from fundamental to other modes, you were clicking some arrows
Oh, this
next
one.
to the plot. Yeah,
This
yeah,
one
yeah.
not
I
there.
don't see it on my
But
version.
yeah, yeah. Your 5 point version, right? Something.
5.2, yeah, right.
So those things are not there. So that's why I recommend in day one that you can install 6.2.
Oh, okay. Yeah,
Yeah.
I think I
So
should be doing it today.
yeah.
Yeah, I will do.
Yeah.
Okay.
So it just a change in GUI. Basically, the core remains the same, but a lot of changes keeps on happening on higher, which helps the user to make the work easy. Okay, how about others? They are able to get this fundamental mode, right? If they are changing the power.
Uttam, my name is Firaz. I am getting different values like 1.01, 1.09. 1.23,
Yeah, so
1.31.
then you can check. Can you check the cladding is 1.4378 and core is
Yeah,
1.4457?
yeah, my cladding is 1.4378, and my
Correct.
core is my core is 1.4457.
Then in mode analysis, have you changed the search for modes around shift to be 1.4457?
Yes, it's 1.4457. Yes.
And the frequency in that wavelength, have you changed to C constant by 1.55 micrometers?
Yeah, C constant by 1.55 micrometer. Yeah.
Okay, then can you share your screen?
Yeah, sure. Can you see my screen? I think it will do it in just. Let's see.
Oh wow. So actually, I think you might have. So it seems that a lot of energy is going through the cladding instead of core. So you might have exchanged the material properties of core and cladding. I don't know. So can you go to the core and cladding? Okay, clad is good. This is 1.43 is good. How about cladding? Sorry, core is 1. That also looks to be good. How much? So much energy is going in your cladding, but I think so. Go to the mode analysis now. This also looks to be okay. So can you go to electrical field surface one? Okay, go to the electrical field that up above this one, and click on effective mode index. What are the weather values? Top that one point. Oh, okay, okay, amazing. So click on 1.3672 last one. Yeah, click on plot. Oh, something we are doing very silly. Okay, okay. So can anyone point out the error here? So these things can happen. Anyone from the
Maybe
attendees?
the boundary, the PEC is
No, no, no,
misset or
not
something.
that.
No.
It comes a very trivial mistake, actually, where many people will do.
Wave equation electric postmodel fractal model.
Sorry, wave equation electric.
The unit is micro
Postmodel
inch.
fractal range.
Yeah, the unit is actually micro inch. Yeah, correct. So you go to geometry, yeah, and change it to micrometers. Yeah, and then you can complete the no, first study, compute the study, and then yeah, yeah, I think then it should work. Well. Yeah, that looks good now. Yeah,
Thank you.
yeah, looks good. Uh, so let me share my screen. Yeah. So now the next thing is to add these electrical fields over here. Okay. So uh, how to add those electrical field is just right click on electrical field and then add arrow surface. Okay. Just getting a call. Just hold on. Hold on. So yeah. So I think you have added the arrow surface. Okay, and you need to plot the electrical field instead of HX. HX. You can also go it with magnetic field, no problem, because it's orthogonal mode, so it will be just almost the same thing. Okay, so you just then click on plot. Okay, and you can change it to be a white color so that it will be better. Okay, or a black color perhaps would be better. Yeah, this looks too better. You can make it a little bit more numbers of arrows and then zoom in to this one. Okay. So this looks to be a fundamental mode. Okay. So I keep arrow surface. I add a new arrow surface hx hy and increase the number of grid points and change the color of the arrows to black. Okay.
Sir, the fundamental mode is degenerate.
Yeah, that's orthogonal mode. There are two modes are there. So this one as well as this mode. So though both seems to be the degenerate modes. You see this, both of them.
Ah, okay, sir.
So both of them are same. Effective in the mode index also the same. And then you go for higher order modes. You see this mode which is going all the arrows, electrical fields or magnetic field. They both are perpendicular, so just complementary. So it's coming outwards, right? So here also you can see we're discussing
Ah, yes.
is coming outwards. Okay. So if I plot the electrical field in this case, it will be circular. Okay. And then here is one more hybrid mode. These are all other modes are there. Okay, so these are all leaky trivial modes. These are all non-trivial modes. Okay, so this is how you can actually visualize a specific mode. Okay, so are you guys able to get this?
Sir, I have a doubt.
Hmm.
Yeah, for how do you change the size of the circle here? Like I'm getting a small circle in my screen.
Small circle. Can you click on this zoom
Yes.
extends?
Okay.
It'll extend out to this whole domain.
Yeah, got it,
Hmm.
sir. Thank you.
Yeah. So any questions?
So
Any doubt?
can you show me again
I
what did you add in arrow section? What
Arrow
to
surface. I've not changed anything. I've made it by default. It is plotting the magnetic field, so I just kept that one. The number of grid points I increased from 15 to 30 for both X and
but
Y.
in placement it is not grid in mine, it's showing uniform, not grid. It's
Which
showing
version of
uniform.
COMSOL are you using?
This trial version 6.2.
In you're plotting arrow surface, right?
Yeah, yeah, arrow surface. Okay, I think I chose arrow line.
Okay.
Okay.
You can delete the arrow line and then create arrow surface. So I'll just wait for a few moments for you guys to explore this one. Okay.
Hello, sir. This is Jay Krishnan.
Mm-hmm.
Sir, I have a small doubt with the higher order modes. How can we number those modes actually? For example, if it is higher order mode like around TE05 or TE15 like that, how can we identify those kind of modes like using
So
console?
these are what you see over here are the hybrid mode. So if you see, there is one course in NPTEL by a professor in IIT Madras. I don't remember Professor Balaji. So in that he has talked or
Balaji Srinivasan, sir.
yeah, I think he or
Balaji
IIT
Srinivasan.
Kanpur professor. I don't remember exactly, but there is nice notes as well. So if you see his notes, he mentioned all these directions. They correlate for a particular modes. So if you do a Google search about that, right, you will get that particular. So all these modes, it's either a hybrid mode or a LP MN mode. Okay, some of the linear polarized mode. So this, uh,
Excuse me, sir.
yeah,
Sir, actually, I'm not getting one mode which the arrows are coming out, like outward. All arrows are coming outward. Others, I'm getting like diagonal arrows, straight arrows, all those things.
this you are not getting. You saying
Yes, 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 sir.
that will be reflected index of 1.4425.
Oh, okay. So we have to change that because
Effective
when
mode
we
index keep on changing, and you can see sometimes there will be some plus minus, but usually it would be around 1.4425 only for you guys. Yeah, if you see
oh
for this 1.4425, you will see that, and this is for the magnetic field. Okay, if you change it to electrical field, you will see that something else will come. Okay, but just perpendicular means it's circular in this case. You see, I will
oh
also
okay.
kind of duplicate it and show you the magnetic field. Okay, so you can see we can plot both of them together. Perhaps I can use it in yellow color. So here you can see a particular mode.
Yeah,
So
yes,
here
sir.
yellow signifies the magnetic field, black signifies the electrical field. I can use the player to understand like how this also how this field are varying. You can see. So I
Yeah,
can
yes,
see
sir.
it to 25 and make it a little bit slower. So you can see that how it is propagating. So it actually helps you to understand what are the physical meaning of that particular mode.
Oh,
Sir, I have a
Yeah.
doubt. For effective mode index 1.44, I was getting some different kind of errors. For this 1.4425, I'm getting different. So I'm not able to connect the change. Whatever you are doing, I'm able to follow. I'm doing same.
Mhm.
I'm getting result, but you know that physics, I'm lagging, and I'm not getting everything.
Uh, can you share your screen, please?
No, no, I'm getting the results,
Okay.
but I'm asking the mode index first I chose by mistake, it was 1.44. That time arrows was somewhere random, not pointing out. Now I chose 1.4425. I'm getting the result what you are getting,
Uh-huh.
but I'm not able to connect what is the change and why refractive index. While changing the refractive index, I got different kind of
No, we are not
result.
changing the refractive index. We're just changing the mode index. Okay, both are
Huh,
different
that
things.
mode index,
Yeah, so
mode.
this all represent a specific mode. Okay, some of them are trivial modes, some of them are non-trivial modes. Okay, so
So how did you know that? How you got that 1.4425 only? We will get this kind of
that
errors.
COMSOL itself figures it out, which are the modes that may exist. If you search for around 200 modes instead of 10, there'll be so many trivial modes that may exist. Okay,
Okay, okay.
so then you
Okay,
need
we
to
chose 10 modes. That's why we are getting this 10 different kind of.
here I search
Yeah,
for
yeah, yeah.
10 modes
10.
right here. So usually the lowest few of them will be having the fundamental modes.
Okay,
Okay, so it's kind of makes a search of mode indexes and then finds out the modes of propagation.
okay, okay.
Okay, so that's how it kind of works.
Thank you, sir.
Hmm.
Hello,
Uttam, I have a
hello.
question. My name is
Sir, I have
Faraz.
this
Hmm.
doubt.
So as you mentioned,
Yeah, Faraz, sorry.
as
Yeah.
yeah. So my just I will just quick wrap my question quickly. So as you mentioned that the lowest value has indicates that this is the fundamental mode, and when we go higher in the values of the effective mode index, then then the order of the modes is getting increasing. Second order mode or third order mode.
Usually,
Then
yeah, yeah,
yeah usually, but here how can we as an engineer how can we understand that let's suppose it's 1.44 is the 1.44 is the fundamental mode and then we have a value of 1.54 let's suppose, then how can we detect that this is the second order mode or third order mode is this 1.54?
yeah. That's what you have to see this electrical field patterns.
Okay.
Okay, how the power is flowing. You can see that in this case, the power flow is
Yeah.
completely in the center. Okay, you can also do an integration of power. Okay, so for example, I can show you, and you can also see that if you do the integration, just right click on derived values, you do the integration, surface integration, and do it for all the modes, and you will see that the power which is flowing for the fundamental mode is going to be differently more. So for example, I'm going to use this P over Z, and then I do it for all of the modes, and you could actually see that how do I do the nanowatt. Okay, so here you can see this for fundamental mode. I can increase this to be having scientific notation. No. Decimal notation. No.
Okay.
Decimal notation. No. How do I increase this? Auto. No. Full precision. Yeah. So if you see this full precision, so then you can actually appreciate that for the fundamental mode over here, the power which is flowing is like significant. You see, 13.22 nanowatt. Okay,
Yeah.
and then usually others one are kind of very low. Okay, I don't know for this one it's having significantly high, but what is this mode? Third last mode. Okay, so here it seems to be, here also is kind of more, but it is at the boundary. But one of the way is to see the power. Okay, usually it's kind of for the fundamental mode is kind of very high. Okay, you can plot it, and you can see this over here. Okay. Okay, so basically you can actually see this direction of your fields. Okay, and from that you can actually you can know what are the modes. Okay.
Hello, sir. This is Dipanjan.
Yeah.
Hello,
Sorry.
So this is
Dipanjan.
Dipanjan. Sir, I have some question. So using the console, we use just some material having some refractive index value. And suppose there is some design that there is used to suppress some higher order mode. So for this design, what they did that in the core section they use some active region and passive region. So using the console, how can we define the active region and passive region having same refractive index value?
I don't fully understand the question. Sorry. How do you define active and passive regions? Means maybe
In the
perhaps.
core region. Suppose there is a design like confined core fiber, and it is used to suppress the higher order mode. So the central region
Means some kind
having
of
the
material you have, means not just a silicon material, some other materials you have, some kind of specific designs you have, some kind of
uh,
channels.
no sir, it is a specific design, and the design
Mm-hmm.
the core section having the refractive index same, but the core section the central core region having the ytterbium along with silica. And the outer section of the core having some aluminum, so it is the passive. So what they did that they amplify the um, first order mode, that is the fundamental mode, and
Mm-hmm.
as it is the Gaussian shape and the hard order mode not getting amplified. So using that, they suppress the higher order mode. So the thing is that in the console multiphysics, the material section, we just define the refractive index. And so my point is that how we separate. So this is the active vision having the ytterbium. So there is a gain occur, and this is the passive. There is a no gain occur.
Yeah, no, no. For gain domain, it's different thing that you need to work with gain and all those things. So you have to write equations for applying gain. Okay, so that is for specifically for laser. For example, people work for gain medium. So specific material. So you need to apply. So usually what people do is rather than positive value of this refractive index, imaginary part of refractive index, they use negative values, which means
Hmm.
that it actually will significant apply for the gain. Okay,
Hmm.
so that material modeling has to be changed. So best way to do would be to check if there are already published papers which have been done with mode analysis of a with the gain mediums. Okay, and what are the material properties that they have choose for. Okay, so try to replicate it in your model and try to replicate the same results from that paper first, and then you can change it based on your requirement. Okay, but the approach remains the
Okay.
same. You need to apply material properties and uh, perform the mesh without physics control mesh. Specifically, if there are very small microstructures, then you try to refine the mesh around that microstructures, then apply a mode analysis around the higher refractive index values. Or if you're planning, if there are many holes and you want the mode to be propagating through the hole, which is kind of vacuum, then you put the search for mode index around 1. Okay, and then you can visualize, see the power flowing through that particular mode. You can see the way the how the electrical fields are behaving that in that particular uh, modes. Okay.
Okay. Okay.
Hmm.
Hello, sir. This is Jaykrishnan. I have a question.
Hmm.
Sir, for example, let's say if I want to select a particular mode out of this 10
Okay.
and I want to calculate the losses for a range of wavelengths,
Okay.
how can I do that actually?
Yeah, so basically you need to first find put a lossy domain. Right now we don't have the losses. So for example, I put the losses 10 power minus 3. Let us me put little bit higher values so that we can quantify the losses very easily. And then I do this study one. Okay. So then in my okay, this again significantly changes. Okay, I need to put very low loss. So everything will keep on changing. Yeah, so now it's fine. Losses are good, less. So now, if you go to derived values, if you go to global evaluation, there's a variable on a damp Z. Okay, so I was talking to earlier as well in dB per meter, for example. Okay, so this the same thing is also given fiber simulator model. Okay, and you can do it search for all of them. So here is the attenuation coefficient for all of the modes. Okay,
Yes.
So this is the way how you can actually calculate what is the attenuation constant, and then you can
Yeah, but
also find the losses from this. So what I recommend is that you can go through this example model. Okay, I will share you this. It talks about attenuation and losses in more details. Fiber simulator app.
so
Yeah.
yeah, like can I talk about another application called numerical FTTD?
Sorry.
So I was also working with another software called numerical FTTD.
Okay.
There I can select a particular mode and I can do the frequency sweep to calculate the losses. Like I can select only one mode. So if I start from one wavelength, for example, 1.5 to 1.6, so it will calculate the losses like from 1.5 to 1.6 for the for the selected mode. So
So
here,
in that case, you need to do a parametric sweep here. So you do a parametric sweep here, and then apply that wavelength sweep over. So
yes,
instead of this single wavelength, you actually do this LDA naught. You write this LDA naught over here. LDA naught is 1.55 micrometers. Okay, and over here in parametric sweep, you add this parameter over here and just search from start from 1.5, step
1.5.
from 1 sorry
No, sir, it has to be
1.0
0.01.
01 and 1.6. Okay, and then you do this. Okay, so then you have for all of them. Okay, you have for 1.5 to 1.6, and from them you can actually so for each frequency you are searching for the fundamental mode. 10 modes you're searching, and then for you can do it. So now instead of one, you will have for 10 16 or
Yes.
10 columns. Okay, for each wavelength you'll get this. You can export it and
Yeah.
then play around.
So from the table only I have to extract the data,
Export,
then I have to plot
export.
it separately.
No, here also you
So
can plot. So they are like plotting features. A table graph is there. So over there you can actually change what is the x-axis and y-axis. All those things you can play around. Okay, so those things are there.
Hello, sir.
If you have multiple columns, that also. Yeah.
I want to ask a question. How to integrate two modes, product of two modes?
Yeah, you need to superpose two modes. You are saying. Hello.
Yeah. Yes.
Yeah, you want to superpose two modes. You're saying.
Multiply of electric field.
Yeah, I mean superpose of two different modes, right?
Yes. Yes.
Yeah, so that's what we discussed yesterday. So if there are two modes, for example, you can and do you want to what you can do, you can perform uh, so how to explain? Okay. Okay, so for example, I have an optical fiber over here. Okay, one mode that I'm getting from this is this particular mode. Okay, so mode, for example, I want to find what is mode overlap. Okay, so another mode that I'm getting is for example, it is this mode. Okay, so there are two different modes. Okay, so both of them are given by the electrical field. Okay, so you need to, and each of them would be having a variable, like this is also E1 for a particular mode. Okay, and then you have for another mode you have another electrical field. So what we used to do is we used to call this solution because each of them is saved in a particular solution. So this is, so right now total 10 solutions are there. Okay, each saving for each of the modes. Okay, so you can call these solutions. Okay, and then you can um, perform a convolution or multiplication of the vectors. Okay, so you see over here, so the data set, so it's a solution of 10 different studies. So while you're doing this, so you want to launch overlap of two modes, or you just want to find this mode overlap, just multiplication of electrical fields of two different modes? Hello, can you hear me?
Yes, sir. Mode
Yeah,
overlap.
mode overlaps. You just need to multiply two electrical fields of two different modes, right? So then you
Yes,
can
yes.
use this approach. So you can call it from a solution. So there is a variable actually that used to be. I forgot what was that variable name. Uh, but I think the same mode overlap is also mentioned in a. I think it's also given perhaps mode overlap is not. So I don't remember it exactly. I can just check it. Jai Krishna, yeah, a lot of noise is coming from your side. Can you please mute?
Yeah, yeah, sorry, I forgot.
Yeah. I'm just trying, but there have been few papers on finding this mode overlap, mode field diameter, mode field. Okay, yeah. So basically, you have to call this. I actually forgot what was that. No, actually, it was. It's it's kind of an what to say function that you can call a specific solution. Okay, so you need to call these two solutions. This all are stored in a particular solutions. You need to call that solution and the variable name and then just multiply it. So there are few works where people have done this actually. So if you go to this mode uh, papers and research, okay, so if you search for mode overlap, yes, so you will actually able to find it. Okay, so people have actually done this mode overlap as well. So how to do overlap and this. So you can go through and you can just try it out. If you're still not able to get it, just let me know. I can try it out in one-on-one session as well. Okay, just share this with you. Okay, you can just go through it and check it. But in meanwhile, I will just try to remember exactly what was that. It's somewhere in this COMSOL reference manual. I'll remember it sometime. Okay. Yeah. Any more questions in regard to this? Okay, looks good. So I hope this mode evaluation is fine and understood. The next thing that we wanted to work was the interface. So for example, we want to make a slab of silica and an air domain. Okay, and I want to propagate an electromagnetic wave from the top. I want to see as a function of I want to add some kind of a nanorod, for example, and I want to see as a function of wavelength what is the transmittance. Okay, this could be an example of a grating. So it could be a square, any structure that we can have to talk about. It's not a problem. Okay, so let us try and build this particular model. Okay, a quick raise of hands of how many people will be doing with me, so it will help me to understand.
Sure. What exactly is it? So you have air medium on top.
Yeah, it's air and silica. So it's
Silica.
actually yeah, so it's actually a structure like this in 3D. If you can replicate it, it would be something like this. So there are nanorods.
Okay.
Okay.
Sir, you said that it's a grating-like structure. So
Yeah,
if
yeah. So it could be either a grating. Means grating means you, if you want, you can have something like this. Okay.
sir, in a fiber, if I want have to design FPG, is the same procedure will be followed?
Fiber grating means that's again in which cross section that you are dealing with. Okay, with fiber we have an example of this kind of longitudinal cross section. So I will show you one example of a plasmonic filter. Okay, So this is a plasmonic waveguide filter. So which has a grating kind of structure. So I can download this and show you. It doesn't show this model anymore. That side. Yeah, so it has this kind of structure over here. Okay, so it has this width and then keeps on increasing and decreasing, increasing, decreasing, and at the surface it has a gold material. Okay, so so that was built using Drude Lawrence as well as with the AG Johnson model, that is gold.
Sir, if I want to design a simple fiber brack grating,
Hmm.
then
Yeah, this is the approach. Similar approach you can do. So longitudinal cross section, and then
hmm,
you propagate this light source from using a port condition, and then you take out from here.
and similarly I have to say take this width and
Yeah, yeah,
dimensions.
yeah. Similar like what we did yesterday. The same thing you need to do, and you will get some kind of this kind of characteristics. For some time, you will not you some for some region of wavelength you will see a very high reflection. Okay, other is actually will work as a filter.
Okay, sir. I'll design it today.
Yeah, yeah, yeah.
Sure.
Yeah. If you face any problem, just let me know.
Okay,
I
sir.
think this
Sorry to
model.
interrupt. This is Jay Krishnan.
Mhm.
Sir, like, so I see in this graph transmittance versus wavelength, right?
Uh-huh.
So can we increase the number of points actually? So we are just giving the formula in the global evaluation. So it is plotting the data for us.
Which
So
example are
can
you talking
we?
about? The one that I'm
No,
showing you right now?
yeah, and not for this one's laser. Like normally, like if I want to increase the number of points that it is plotting, can I do
Increase in
that?
the number of means
Points,
wavelength
plotting points.
points means plotting points.
Yeah.
Sorry. Okay.
Sorry. So this graph can be plotted with 100 points. For example, 100
Yeah, yeah, yeah,
transmittance
yeah.
data for
Correct,
100
correct.
wavelength.
Yeah. Mm,
So in the same way,
correct.
is it possible to increase the number of points to get more accuracy?
Yeah, yeah,
Like, can we do that
yeah,
in
yeah. So that
COMSOL?
we'll do once we do this example model. This one that we are trying to say. This one.
Okay.
This one we are trying to do that. That time I can show you how do we get it. Yeah.
Okay, sir. Thank you.
Okay. Looks good. Okay. So let us start to build this model. This is day two. Day two. So I'm making a new model. Just to save time, I'm making in 2D because in 3D it will take more time to solve even in your system. So let us choose 2D simulation and go ahead and choose optics, wave optics, electromagnetic waves frequency domain and click on add. Okay. Same thing that we have been keep on adding till now and click on study. And you can do either wavelength domain or frequency domain. Anything is fine. You can use wavelength domain as well.
You have selected 2D or 3D?
2D.
2D. And in wave optics, we have selected the same frequency domain, right?
Yeah, frequency domain. Yeah. Okay, and click on done. Okay, so we will be doing a parametric sweep of the wavelength. Okay, so you can put this wavelength here, and perhaps it could be around 600 nanometers. We will wait for a few moments for you guys to add this parameter wavelength. Then we'll go ahead and make the geometry. Okay, so I hope you have added this wavelength. Next thing is to change the geometry unit size, so make it in order of micrometers, let us, or nanometers should be better. So you make it around same in order of the wavelength of operating wavelength. So we see some kind of effects. Okay, looks good. So you make it in order of nanometers, so we can put hundreds of nanometers. That is fine. Okay. So next thing is to make a rectangle. Rectangle, we can make it about width of 1000 nanometers and height of around 2000 nanometers. Let me just see that. How does it look like? Okay, so you can make it around 600 nanometers. Single.
Is it necessary to mention nanometer in the brackets? Because
No, you don't need to mention this. Best
okay,
practice,
yeah.
actually. So sometimes we might do some mistake on the units. We might not put something. So it's a best practice method. So yeah. Okay, and you can actually make this base as center, so that it actually goes to the center, and then just click on zoom extends. So the center is your center of the geometry. Yeah, a quick raise
Uh,
of hands of how many people are doing with me now.
excuse me, sir. How did you make
Okay.
it center?
Yeah, you need to change this base to the center. By default, it is corner. You can change it to the center.
Oh,
And click on build all and then zoom extends.
okay, sir.
Mhm. Okay, looks good. So the next thing is to add two different domains in over here. So one way, a simple way, is to add a layer in the bottom. By default, it is in the bottom. So I can make it like 1000 nanometers. So it will something like this in the. So over here, it's just surviving over here, so something like this. Okay.
Sir, instead of taking the second rectangle, why we have chosen the layer?
Yeah, this is again kind of best practice. So always it's like better to use as much low number of elements over here, because as you go on making more complex geometry, it, it's kind of, yeah, you can again use another rectangle using those things. So but yeah, using of layers is always easy actually. Okay, multiple layer structures you can add multiple layers here, and that actually makes the life more easy. Okay. Okay, any questions or doubt till now? Okay, so let us add a small rectangle now, which actually replicates. So let me show it around 50 nanometers by 50 nanometers. Where does it lie? Okay, over here, right? So, so I'm just trying out something. So it may not even work. I don't know. So don't worry. But the approach what I am trying to show is that it should always work. Okay. So what I did is now I add a small kind of a grating structure. Could be this could be a metallic material, which is like 100 by 100 nanometer in size, and I just offset it by 50 nanometers because I want it to be in the center. Okay, so you see this, and this is aligning over here. So if I don't make it zero, then it offset to the right hand side, right? So which I don't like it. So try to make it in the center. Okay. Uh, and actually if you So this is a unit cell. So these things are getting repeated again and again. So if you change something over here, then it gets reflected everywhere. Okay, I hope I will wait for a few moments for you guys to add this.
Sir, once can you open that farm union?
Which one?
Farm union, rectangle to below.
Okay, this one you're saying about?
That one only.
Sorry,
For me, yeah, that one only. For me, it's showing in different color.
color. Don't worry. That those things are ones should be fine. Just see, make sure that you're getting this structure similar to this one.
Yeah, structure is getting, but
Yeah.
color I'm
Just
getting.
if you click on build all, right, it will change it then. Once you click on
Okay,
build all, it will be same thing. Okay.
okay, thanks.
I hope you are able to get this structure now. Everyone? No problem. Okay. So
What is the
next thing is
dimension
to
of
add.
rectangle? This is
Sorry.
This is pen. What is the dimension of rectangle?
Sorry. Is it whom?
Pen.
Your voice is kind of very low. I cannot hear it.
What is the dimension of second rectangle? That is mentioned.
Second rectangle diameter dimension is 100 by 100 nanometers and offset in acceleration by minus 50 nanometers. Okay. Nanometers, 100 by 100 nanometers, and is offset by 50 nanometers. So it's actually in the center. Okay, looks good. So next is applying the materials. To apply the material, just right click on material, add material from library. We go and choose the air material. So air is given to all the three. Don't worry. Next is apply silica glass to the bottom material. Okay. I'll wait for a few moments for you guys to add both this material, and then let us add the uh, gold material to the top material. This one.
Uttam, how did you add the
So
silicon
could you
glass
please
material?
repeat materials in
Yeah,
that you added air?
yeah.
So,
Air is over
oh,
here.
oh, okay.
Yeah, silica glass is over here. Um,
So-
yeah,
And the bottom one is silica and the top is the air, right?
yeah, correct.
And
So I've
the
not yet
little
given this material
rectangle.
property. Yeah, I will give in some
Okay,
time.
okay. Sure, sure.
Hmm. Yeah,
How to get this silica glass material?
it's in the air built-in material. Just double click on this and then select this domain.
Okay.
Okay, so I hope you have added these two materials. Next thing is to go to optical materials, inorganic material, cold, experimental data, and then choose and add the Johnson and Christie. So here you can see which wavelength range does the material property support. Okay, so you most of the time people use the Johnson and Christie. So just double click on it and then assign it over here inside. Now this is what is different over here is that it is a wavelength dependent material property. So based on the wavelength, the refractive index is changing. Air, I'm assuming it's not changing. Even the air silica glass, I'm assuming it's not changing. The wavelength is not, the refractive index is not changing. But for the gold, I have now mentioned it to change as a function of wavelength.
So I have a doubt.
Hmm.
Yeah, actually, for me in my screen, in materials, in under inorganic materials, I'm not getting gold.
Inorganic material, gold.
Only two options are there.
Which version of COMSOL are you using?
The one which you shared.
Okay. Did you install all the modules while
Yes, yes,
installing?
sir. Yes.
Okay, can you share your screen?
Okay, just give me a second.
Oh wow. It seems that you have not installed all the modules. Uh, how come it is not showing? That's strange.
Yeah, this is what I'm getting.
Yeah, no, actually, you might have. Yeah. How about others? Are you guys able to add the materials? Gold?
Yeah, Uttam,
Excuse me, sir.
I have.
Sir, could you please explain that step once again? Adding
Yeah.
gold.
Yeah, I will share you. Faraz, you had a question?
Yeah, just wanted to just you were telling me just telling in the video in that just few minutes before that now we are changing the properties of the material. I think you mentioned, but I
The
missed.
wavelength
Could you
dependent
please?
material properties. Yeah. So
Okay,
this is all this in optical domain. All of this
yeah,
are the wavelength dependent material properties. Okay. Yeah. So this is what we are using now. So what we do is that just right click on materials, then go inside this. So till now we have worked only in built-in, but now we are going
yeah.
to optical. Inside optical, go to inorganic. In that you can go to gold and then go to experimental data and then double click on this one, AU cold, Johnson and Christian, assign it to the central domain. Okay.
Yeah, I have done it, but what does it mean by the value 1972 NK 0.188 minus
Yeah, so
1.9?
this was Johnson and Christie are the developer of this material. They have
Mm-hmm.
characterized this gold material. N is the real part, K is the imaginary part, and this model is from 1.882 sorry 0.188 micrometers, that is 188 nanometers to 1937 nanometers. Okay, so if you go inside this, go to refractive index and interpolation function NR. This is the real part. This is the imaginary part. So if you just see plot them, you will see the plot. So it's a function of the wavelength. So x-axis is the wavelength, y-axis is the real part of refractive index. Similarly, over
So,
here is the x-axis is the wavelength, y-axis is the imaginary part of the refractive index.
okay, so when the
Sir,
wavelength is changing, the refractive index is also changing, right?
Correct, correct. The both real and imaginary part is
Perfect,
actually
perfect.
changing.
Okay, thank you, thank you, thank you.
Mhm.
sir, in my model, I don't think so that there is anything as Johnson and Christie, but there are other Hagman, Johnson.
You
So
can choose the.
Johnson would be one.
Okay, can
Would
you
you
share your
suggest me to
screen?
put Johnson?
Yeah, I will
Okay.
just look into
Uh,
it.
yeah. uh, yeah, I think this is
Oh
the
my God.
one.
No, 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 no.
So,
Where are you gone? Uh,
so
can you go up a
in
little bit?
yeah,
Okay, this looks good. Oh, okay, okay. I see. This is 5.4. Oh,
yeah. So in
you use
organic
EU Johnson.
material.
Yeah, yeah, yeah.
So there is
EU
one
Johnson.
Johnson. So can I select this one?
That is fine. Yeah, just double click on it. Just close this. Assign it to the double click on this. Is it come? It has come. We apply to the central domain
Yeah,
and yeah,
it's
and but
selected.
the
Yeah,
you can see the it go inside this material
yeah,
on the left hand side. No, no, no. Inside this AU Johnson and see the refractive index, real part and imaginary part. Uh,
yeah.
yeah, no, no. On the left hand side, this small triangle is there, right? Can you open the triangle? Go again. Open the triangle for. Okay, now good. That interpolation function is n inter. That you click on that and plot it.
Mm.
Yeah, so it's a function of wavelength. Same thing actually.
Oh, okay.
Yeah. That's good. So sometime because you change a lot of screen, you might get stuck, and you don't go to the default view, right? So you can go to the home and go to reset desktop. It will reset to the original setting. Sometimes you might go like this, something goes missing, for example messages goes blocked, this guys goes the settings like this goes blocked, so difficult to get it through that. Just click on reset desktop and it will go to the original positioning. Okay. Wait, so I wish you also need to add air and silica. I hope you will add that in break. Okay, so
Sir,
yeah.
so now we have three refractive indices like silica, gold, and air should be there, right? The upper.
Yeah, air is the top part, silica is the bottom part, and then the gold is the middle part. Okay.
Hello.
Mm-hmm.
Sir, what I'm supposed to do to install all the modules?
You to run the setup again and select all the modules while you're installing. In the break, you can again start the setup again, and you just install all the modules. Okay.
Okay. Yeah, fine.
Mhm.
Thank you.
Mhm. Okay.
So
So
this is Jay Krishna. Yeah, yeah,
okay.
carry on, sir. Like I'll ask the question later.
No problem, right? So yeah. So let us take a break of 30 minutes and then come back at 5 o'clock, and then take this model forward. Thank you. If you have any questions, you can type down in your chat box. I will look into it once we come back. Thank you. Hello and welcome everyone for the next session. So,
Sir, I have one doubt. I'm unable to add these materials for these surfaces. Can you?
which material you are unable to add?
Yeah, three also, sir. It's showing some error.
No,
Can I
which
share
material?
my screen?
Air or gold or silicon?
All three, sir. First, I'm trying to add air. For that one only, it's showing error.
Oh,
Can I
can you
share
share
my
your
screen?
screen? Yeah.
Yeah. Yes. So now, can you see? Sir, can you able to see my screen? Sir,
Yeah. Sorry. Uh, can you share your screen? Yeah.
yes, sir. I'm saying.
Yeah.
It's
Okay.
showing
Just
some cross marks.
just double click on the air.
Yes.
Yeah.
Yes, sir. Now I.
Yeah. So you can select the air to the top domain. Similarly, the silicon domain in the bottom domain.
Okay. Sir.
Okay.
Okay.
That's good. How about others? Any other questions you have? I see there's a question from Jai Krishna. Yeah, you can share your screen perhaps if you are facing this problem. Are you around, Jai Krishna?
Yes, sir.
Yeah. Are you facing this problem in your model?
No, sir. It's not a problem actually. It's kind of a logical error, I think so. So I usually used to get the RA data from refractiveindex.info website. So
Okay.
usually we will get it in a text format. So I'll just use the interpolation function to import those data.
Mm-hmm.
So there I'll name some random words to a function. So usually the t is actually the function, right? Which is actually the wavelength in the interpolation
T is
function.
the argument, which is
Yeah,
actually
which is
the
actually the
wavelength.
wavelength, which represents the wavelength.
Mm-hmm.
So in the parameters also, I used to define like t is equal to the what for the wavelength I have. If I use a parameter, I'll use that parameter.
Mm-hmm.
So in the refractive index, that column, so value column, I have to enter n of t.
So if you choose this interpolation function over here, if
Yes,
you can see
yeah,
my screen, so here
yes.
T represents the wavelength which has a
Wavelength
unit of
micrometer.
micrometers,
Yes,
and this is the refractive real part of refractive
yes,
index. So this
yes.
table you can input.
Yeah,
For example, if you can save it actually, and you can see how does it look like. Okay, this is an R, and it could be either .txt or
yes,
.dat. All those things you can actually look. So it will look like something like this, and
yes.
same thing you can input, and then change.
Yeah.
For example,
So,
if I input interpret function over here,
yes,
instead of this I make it file, and then I browse the file, input this one. Okay, so it looks something like this. So and click on import. Okay, so I will get something like this,
yes,
and here I change it to micrometer and
yes,
function as 1.
yeah.
Okay, and then I just so I can use this interpolation function instead of that. So int1 of
T.
here I can here while defining here I can write int1 of c constant by frec.
Yeah, why we have to use if I use this c constant divided by streak, I'm not getting that error, unexpected unit of input. But instead, if I use the t, I'm
No, you
getting
don't need to use to t here, because if you use interpolation function outside or
okay.
inside also, you to because this frec is a internal variable. Okay,
Yes,
so frec means whichever the
frequency.
study is using
Okay,
that particular frequency, it goes inside, and that is the frec. So it will
but
consider
both
as
are similar,
wavelength.
right, sir?
Sorry.
But both are wavelength, right? Both are wavelength. But why
So
that?
if you're doing a parametric sweep, then it is fine. But this is the more apt version of it. So best way is to use this same thing over here. and based on the wavelength, whatever is calculated, it's kind of a lookup table. So based on that wavelength, it will put this value of this refractive index, and homogeneous medium completely it will give you that 1.53, for example.
Okay.
Yeah.
So it's like
So here, for example, you're saying you wrote LDA naught.
yeah, not LDA naught. There T, but in the parameter section, T is equal to LDA naught. T is equal
T
to
equal LDA naught. No,
yeah,
no, you don't need to do those things. You best is to go with this formulation.
yeah, but
This is
both are
how.
same, right?
Uh, no, but because this is the internal variables that you. So you need to make sure that all of them units you need to mention everywhere. So you need
Yeah,
T
yeah.
equal to LDA naught. LDA naught is what you need to mention, that units everything. If you make units to be correct, then it will not be a
But I'm
problem.
not getting any error in the results, sir. Nothing was there. So
Correct,
my
correct,
results
correct.
are
Yeah,
all are
yeah.
right.
So it's just
Can I
how
share
it
you? Can I
represents.
share my screen to
Correct.
you?
Yeah, yeah.
Just a minute, sir. So can you see it, sir?
Yeah.
Just a minute. Here, 1 minute, sir. Sorry for that. There is a technical issue.
No problem.
So this is my structure actually. So, so I have added the materials in the global definitions there, which is using an interpolation function. Can you see this, sir?
Mm-hmm.
So I have defined one and micrometer and all those things. Here I have written like this. So I'm getting it, which is underlined in yellow color, and it is showing unexpected unit of input, but which is not doing anything to my results. Which is not
Mm-hmm.
which is not creating
Okay,
any
okay.
problems for me.
It's just a warning. If it's yellow color thing, it's just a warning. So what it means that unit of input means for what? NR. So if you go down, how are you? No, no, how are you defining NT? Go to the units of NT. No,
Yeah,
no.
here I'm
Go
defining
NR. How are you defining? No, no. This NR. Go down. Okay,
here
this
this one
units.
function name.
Okay. Now go to refractive index again. Yeah, understood. Yeah, this is 1 micrometer. NR of T, right?
Yes, if I put
Units
C
are 1
constant
and
divided by 6,
180.
it will be fine only.
Okay, okay. Now go to these parameters again.
If I
Parameter
put
1.
C, 1 minute. Okay, sir.
Yeah,
Now I won't get any error here.
correct,
If I go
correct.
to the
Yeah.
parameter, I define this also. Lambda is I have mentioned here, and T also I
Okay,
have
okay.
given here.
Okay. So how about if you put it as uh, L naught, then also you're getting the issue.
L not I will get a red error. Like it don't consider that.
Oh, okay, okay.
I think so.
Yeah. Okay. Yeah, I don't know. Man. So this if you can just cross check while after doing the modeling, you can see the properties of this material. Is it same thing what it is you require or not? Just make sure. You can also
Yeah,
post process the material properties. Okay, so you can just cross check. Even though this is not showing an error, just cross check
yeah.
it is using the same material properties that you require for each wavelength. For example, for a wavelength of 600
Maybe.
nanometers, yeah,
So
refractive
what I'm
index is
thinking is
1.5, for
console is
example.
not recognizing. Yeah, yeah. What I'm thinking is console is not recognizing in this way of defining the material property. Maybe.
Yeah, could be. I don't know. Yeah, this I've never tried this, but usually we put only C const by frequency because we want the solver, the variable from solver directly. So also here, problem is, are you doing a parametric sweep of wavelength?
No, sir. No, no. Like mode analysis only. Like actually, we'll
Oh,
do
okay,
the mode
okay. More
analysis and
analysis.
we'll get a result like this.
Yeah.
That's it.
Okay, okay. I see. Looks good. Looks good. Yeah. Looks good. Yeah. So if you're not getting any change in results, then it's fine. Don't worry. Yeah. Just
Okay, sir.
cross check
Okay.
the material properties
Cool.
are the same. Yeah, you can ignore the
Yeah, yeah. Sure.
warnings. Should not be a problem.
Okay. Okay. Thank you, sir. Thank you.
Okay, I think Suja has created one LinkedIn group. So yeah, so if you guys are interested, you guys can join the LinkedIn group as well. Looks good. Yeah. So any more questions or shall we
So
start?
yeah.
Yeah.
So can I share my screen? Actually, in the material section, when I see material one, I see the top rectangle is selected. In material two, I don't see anything selected, but down when I go,
Can you share your screen, guys? I
yeah,
don't know.
yeah, yeah. Just a second. Yeah. So in material one,
Yeah.
this is selected, and material two, I don't see anything. But here, when I go, air is this.
Oh
This
my
is
God. How many
selected.
materials you have? No, you do
I
one
don't
thing. You
know.
delete material one and material two and material three. Just delete them.
Here?
Right click the material one and delete it. Right
Oh,
click
should I
material
delete
one.
everything? Okay, just
No, no.
a
You
second.
delete material one, two, and three.
Yeah, I'm deleting
Don't delete
three of
anything
them.
else.
Yeah, I deleted three of them.
Yeah. So now it looks good. So you just see the air. Is it there in the top domain?
Yeah,
Okay.
yeah.
Looks
Now
there you go.
it's
Uh,
showing here, but the third one, where do
uh, Click
where
on
is the
air
third?
gold. Left click on AU Johnson.
Okay, okay. Yeah, yeah, yeah. So it's selected.
Looks good,
So
right?
in
Okay.
materials, we don't need anything. I right clicked it and I added some material and then
Now you
I
already had
tried
three
to select
materials,
it.
right? That's it.
Exactly. That's why I was okay, okay. Sure, sure. Um,
Looks good.
stopping.
Okay, so let me share my screen. So I think we all are at this particular step where we have added all the three materials: air, silica, and gold material. The next thing is to apply the source condition because we want to do this scattering parameters. So we use ports. Okay, so right click on electromagnetic waves, the same thing that we did earlier. Okay, so you port condition and apply to the top boundary, and you can apply a periodic port. Okay, give excitation of wave to be on, electric mode field to be like in x direction, so the electromagnetic plane wave is polarized in x direction, and that's it. Okay, I will wait for a few moments for you guys to add this.
Sir, can you repeat please? Actually, your voice is breaking sometimes. So,
Okay.
can you repeat please?
Okay, no problem. So if you just right click on electromagnetic wave frequency domain, you click on port. Okay, once you click on port, you need to apply it to the top boundary because you that's where the electromagnetic wave is going to start propagating downwards, and then type of port as periodic. Okay, uh, wave excitation is on by default, and mode field amplitude as 100 mode field amplitude, and no other change required. Okay, this one more step that we need to do is that add diffraction orders. So this you can also do it. Just click on add diffraction orders and you can see the higher diffraction orders to be added. In this case it's just orthogonal polarization. If you are working with 3D, then more number of higher order diffraction orders might be added. Okay, so you click on add diffraction orders in the bottom. Okay, similarly I need to add one more periodic port, so I just right click on electromagnetic waves frequency domain, apply another port boundary, apply it to the bottom part, type of port as periodic again, wave excitation as off, mode field as 100, and I change my refractive index over here to 1.4, same of that of glass. This is 1.45, sorry, so 1.45, and then I that's it. So here, if I do it diffraction orders, if I add, yeah. So
So can you
again, you can,
explain the reflection order again?
yeah. So for which port? For port one,
Port
port
1,
two.
yes, port 1.
Yeah. So in port one, you just need to click on add diffraction orders. Okay. But better would be if you add the port two and then you add it. Then it's better. So once you add the port one, port two is type of periodic port. Type of port is periodic. Wave excitation is off. Mode field is 100, and include in automatic diffraction order calculation, use refractive index of 1.45. Why 1.45? Because this boundary is associated with silica, and the diffractive index of silica is 1.45. Okay, and
Uh,
then, yeah,
Sir,
sorry,
port 1, the refractive index is that of air, right?
one air, yeah, because this boundary is associated with the air, so you give it as air. Okay,
So by
and then you can go
selecting
to
this, I'm not
hmm,
getting
hmm,
this
sorry.
orthogonal polarization. I'm not getting.
So have you selected this gold material?
Yes, sir.
Okay, can you show your screen?
Yes, sir.
Yeah, I think this is the older version, right? So
Yes,
perhaps
sir.
it's
It's
not able to
5.3.
add, so you have to manually add it. But that's fine. It will not change much of the results because that particular higher order diffraction might not be much
So here
significant.
it is the option of diffraction order by right clicking the port
You can
1.
add it by default as well, so that's not a problem. But it's fine. If you don't do it, it's fine. That's not a problem. Okay.
So
So
in
what should I
port
do? Should
2,
I add it or
No,
not?
you don't. No, no need to add. It's fine. Or if you want, you can add it. You can add a out of plane vector. Okay, out of plane or orthogonal polarization, and then diffraction order, orthogonal polarization, and then diffraction order is 0 and 0. What are you getting? Out of plane diffraction order, out of plane only, or no? Orthogonal polarization is not there.
Nothing, nothing. So
No, then don't add it. It's fine. Better not to add. By default, you keep it what it is. Yeah,
Uh,
it says. Yeah, sorry. Tell me.
Excuse me, sir. So
Hmm.
for port 1, I could add this orthogonal polarization, but port 2, it is not, like it is not coming actually. That
Yeah,
study
so
path is not
once
there.
you go to port 2 and apply this periodic port of mode field of 1, refractance is 1.5, and then you go to port 1 again and then
Okay.
click on add diffraction orders.
Oh,
Okay.
okay, okay, sir.
Yeah. Even if you don't add, it's not going to do much difference because not much, not higher. Usually there are like 10 to 15 number of higher order modes that exist. Okay, higher diffraction orders that exist, right? So in this case, they are not much significant because our geometries are not difficult. Even we are not talking about in 3D, so it's not a big problem. Yeah.
Sir, so in diffraction order for port 1 and port 2, so do we need to change this in plane vector or out of plane
No, no,
vector, or
don't do
should we keep
anything. Don't change anything. Just
just keep everything
but
default?
as of now, you keep it same. Whatever you're getting.
Okay,
Okay. Yeah.
thank
Okay.
you.
That's good. So next is any guess? What will be the next step?
Applying boundary condition.
Yeah, periodic boundary conditions. So just right click on electromagnetic waves frequency domain and then apply periodic condition on left and right. Apply flow grid using the periodic port.
So
Could you please repeat how did you apply the periodic condition?
Yeah, just right click on electromagnetic wave frequency domain and apply a periodic condition over here.
So first of all, we have to select all the boxes and then click on periodic condition, right?
Sorry, you just need to right click on electromagnetic wave frequency domain and
Okay.
click on periodic condition. Once you go to periodic condition, you need to select these two left boundaries and these two right boundaries.
Thanks.
Sir, are we selecting these boundaries and taking flocate periodicity because this is a unit cell and this is going to repeat?
Yeah. So eventually this structure is going to repeat equal distance. It's infinitely it's going to repeat on the left and right.
And what is the significance of this flocate periodicity out of the
Look at
three?
right now we are having angle of incidence of 0, right? So
Hmm.
you can instead flocate, you can also go to continuity, normal direction of angle of inclination. But if you have any higher angle of inclination like 10 degree, 20 degree, 30 degrees, like 80 degrees angle of incidence, you understand what is angle of
Yeah.
incidence, right? So
Yeah.
for
Yeah.
higher angle of incidence, flocate is a more robust way of approach of applying periodicity because it works with both phase as well as electrical field. If you apply only continuity, it
Yeah.
will give only to the each node points. It will just copy paste what is the electrical field from here to here. With flowcate, you are also doing copy pasting of the phase. So
Oh,
what is
okay.
phase over here? Same phase also get pasted over here.
Okay.
Okay, so that's it. So that's it. So just go to the mesh and click on build all. Okay, one thing that we have not yet added is the operating wavelength. Okay, so you can actually over here you can choose this LDA knot. Okay, and right click on study one and click on parametric sweep and add this LDA knot. Okay, I will just wait for a few seconds for you guys to add this in wavelength domain LDA knot, and then add a parametric sweep by right clicking on the study one, click on parametric sweep and add this LDA knot, and then I will mention how to add this material, sorry, this parameter.
sir, could you please repeat once again?
Yeah, just go to wavelength domain. Okay, in the wavelength mention LDA knot.
Okay.
Okay.
Hello, sir.
Yeah.
Sir, can you repeat for port 1 and port 2?
Port 1, you just change the type of port as periodic, apply to the
Okay.
top boundary, excitation
Okay.
is on, mode field 100.
Okay. Okay, sir.
That's it. Don't change
Port
anything.
2?
Port 2, just make it as off. Okay. And I don't know why the port name was 3. You can make it 2 actually. So ideally should be 2. So you want to S21 parameters you want to find. So just make sure it is 2. I don't know why it became 3.
The
Okay,
port
yeah,
name is
yeah,
2.
3 because this one has is 2. Okay, I see. So we need to find S3 one then for transmittance of that.
Type of port?
Type of port
Periodic.
is periodic. Wave excitation is off.
Okay.
Mode field is 100.
Okay.
Okay,
100.
that's it. Don't worry about the diffraction orders as of now. Doesn't matter much as of now. Okay.
100. Sir, I cannot put the value of when.
Sorry.
It's okay. Automatic diffraction order calculation.
Yeah. Don't worry
In
about that.
ESP
That's fine. Don't
124.
worry about that one as of now. Okay. Yeah.
Sir, the step of
Then,
the wavelength,
Yeah.
the
Yeah.
sir, after port 2, then
Then you apply periodic conditions. Just right click on the electromagnetic wave frequency domain. Apply periodic conditions. And periodic conditions apply to the left and the right.
sir, please repeat. Periodic condition.
Yeah.
Then
Then you need to apply to this left two boundaries and right two boundaries. And
okay.
type of periodicity as flow quit.
Okay. Then
And k vector for flow quit periodicity as from periodic port.
okay, sir.
Okay, and then you need to go to the wavelength domain change the wavelength to LDA naught. This is the same parameter that we have used.
Wavelength domain.
Yeah, wavelength domain.
Parameter.
Yeah, in this you need to write LDA naught.
LDA not 600 nanometer.
No, just write LDA naught.
LDA already I have written
In the parameters you
the
written
parameter.
LDA
LDA
naught,
not
the
is
same.
600
Yeah,
nanometer.
no, just write LDA naught over here because we need to do the parametric sweep. Okay. Once you add this LDA naught, you need to click on over here, and then you need to click on over here to add the range. So yeah, you want to do a parametric sweep from 400 nanometers with a step of perhaps 25 nanometers or maybe 20 nanometers, and till around 700 nanometers, for example. Okay, and then just click on replace. Just wait for a few moments for you guys to add this.
Wavelengths in
Sir,
LDA not then.
Yeah, just click on this range and then add this step from 400 to 700 with a step of 20 nanometers.
Sir, can you repeat how to add that parametric sweep?
Yeah, just click on this one, range operation. Once you add this, click on add, you'll get LDA naught over here. Then you click on this range operation. And
No,
then you
sir.
add.
Sir, how are you getting this parametric setup? That I'm not getting.
Right click on study one and click on parametric sweep.
400 to
Step of 20 nanometers and stop at 700 nanometers.
okay. Sir,
Sir, there are
And
nanometer
click
is
on
mentioned.
replace. Yeah, if you mention it's always good because it's a best practice method. You put units along with whatever numbers you put.
Okay.
So you don't do any mistakes.
And then function to apply to all values.
Yeah, just replace this one. Click on replace and you should come something like this range
Is
operation. So don't worry about this unit over here because you have anywhere mentioned over here, so it doesn't matter what you mention
Then
here.
sir, add or replace.
Yeah, replace.
then.
Yeah. Yeah. Any questions till now?
Sir, this range.
Yeah, this is a range operation. So what is the question?
So what to fill in this start, step, stop?
Yeah, if you click on this range, the start you mentioned is 400 nanometers, step of 20 nanometers, and stop at 700 nanometers. So you're doing a parametric sweep from 400 to 700 with a step of 20 nanometers.
Sir, there was internet issue, so I missed this. The how to assign the range where I can get that access of the
Yeah,
range.
so this is the button of range. So once you add the LDA
Oh.
naught, you need to click on this range. Then you can
Oh.
mention this, what I mentioned here.
Hello, sir.
Yeah.
Sir, there is an occur. Can I
Sorry?
share my screen?
What happened?
When I go to for compute, then there
No,
is
you don't please on compute as of now because I've not told you to do now. Okay, so
Okay,
you
sir.
go with the same pace that we go with the class, right? Yeah. So how about you guys? So are you able to add these materials as of now? This parametric
Yes,
sweep?
sir.
Any point? Okay, that's good. So then you just see the mesh while you click on build all. You should be able to resolve this particular structure. Okay, so you can see that the mesh on the bottom domain is significantly, not significantly, a little bit more finer as compared to the normal mesh to the mesh that you see in the air domain. Okay, that is because the refractive index of the silica glass is more as compared to the air. Okay, so those things you should be able to observe. But plus the gold domain that you have over here, right? So the mesh that we have done as of now is not the most appropriate. So can anyone guess like why it is not the most appropriate? What are they missing in this mesh? Any guess? Any intuition? What we are doing, we are passing on electromagnetic wave propagation.
Yeah, because the gold is dimension of the much smaller.
But even something more we are missing other than that dimension of the gold. But we are missing to resolve something. Can you guess what is that?
So the boundary is
No,
established
this right
using the
now it's
lambda
with
by
lambda
5
by
by
5 by
n.
n, so that's not a problem. Else we are missing. We already are resolved to the lambda by 5 by n, so that is your physics control mesh is enabled. So that's not a problem. Can you guys guess what are we missing? So if we incident electromagnetic wave propagation on this conducting media, what do you think we'll get?
Reflection.
There is a
Yeah. So
excitation of electrons
yeah,
based on the
Plasma.
well,
metals.
this is
Plasmonics.
the gold material. I am giving an electromagnetic wave propagation to this. So what will happen?
Oh, there will be a
Plasmonics.
reflection as well.
Yeah, there will be a
Scattering,
reflection, but
scattering.
other thing was plasmonics, right? So what is
Uh,
means plasmonics is a very
get
so
polarized probably.
polarization still will be there, but what else
It's
will be there
evanescent phase.
nanoparticle?
Evanescent.
Sir,
Yeah, events. What is
surface
another word of
plasmon,
events and waves? What will fundamentally what will
surface
happen?
plasmon polarity,
Field will die.
Plasma.
surface plasmon,
Yeah, fundamentally what
Resonance.
will happen on the surface?
Resonance. Resonance.
Resonance.
Calculation of conduction.
Resonance will happen, but yeah.
The
Propagation. The resonance
Scattered.
will
field
Okay.
electrons, actually the field inside the
Hmm.
we will
material
get
and
any
all the
polar ion will be
material electrons will
surface.
come.
Okay. Yeah, correct. So eventually we get some kind of plasmons. Eventually, what
surface
I was looking
plasmon
for is
polarity,
yeah, correct. So eventually there will be surface currents.
Surface
Okay,
currents.
surface currents that get in. And if you actually somehow are able to see this field will actually die down exponentially, and the dying down with this distance, where it is actually
Screen
I
depth.
not I not by this e value known as what? What is the depth?
Skin depth. Skin depth.
Sir,
Yeah, skin
Skin
depth,
depth.
correct.
don't we require the Lorentz model here?
Yeah,
Root
you
Lorentz
can
model
use
in
Drude
the
Lorentz model as
physics?
well. So there are multiple ways of approaches. Drude Lorentz model eventually will give you the same thing. Okay, because we are solving the Maxwell's equation.
Then what's the
Yeah.
difference in that
So in that
procedure?
example model, if you see that we talked about some time back over here. So here, if you see, we have done with two approaches. One is changing the material model as well as applying the material itself. Okay, both the ways you see over here is a Drude Lorentz is there. Another is applying the material itself. Okay, so both of them are going to do the same results. You see, both of them are showing the same results. Okay, so you can approach any of the either you apply the Drude Lorentz model, giving the resonant modes, or apply the material conditions accordingly. So, but important thing is that we should be able to resolve the surface currents. Okay, and that is we need to apply some. Uh, so the mesh should be resolved on the surface of my gold or metal conductors. To do that, first I need to find the skin depth. So you know what is the formula of skin depth, right? You can find out, right, for this
1 to
operating
1.
wavelength. Yeah. So I think we have this transition boundary condition which actually helps us to find out this skin depth calculator is there. So if you find what is the conductivity of the gold, permittivity this one, and then C constant by, so you try to find out for the lowest um, wavelength, because it is inversely proportional to the frequency. So its lowest is around how much? 400. Okay, and what is the conductivity of gold? electric conductivity of gold, around 4.11 into 10 power 7. So almost like this one. Okay. So the skin depth is around 2.9 times 10 power minus 3 micrometers. Okay. So around almost like 2 nanometers, right? So I will just disable this. This I found to just find the skin depth. You can also use a skin depth calculator. Okay. So ideally we need to apply boundary layer mesh over here, but let us not go into that involved as of now, because I will do that after some time. Okay. So now just let us run this parametric, because if I do that, then many people will get lost in doing that. So I don't want to do that as of now. So just go to the study one and just make sure that it is LD and not. Don't worry about the unit length, and then you should click on compute. Okay. Then see if you are getting some results. Once you get some results, then we can play around with this boundary layer mesh. Yeah, so it starts to compute for it. Has done for one, and then is going for the next. It's computing for the all of them. Okay. So the most relevant example model to what we are doing, if someone is lost and they want to refer it later on, be plasmonic wire grating. Okay. It's this one example in gratings and metamaterial. Over here to simplify, I think they have not used gold, but they have used a single material, I guess. Plasmonic wire grating, this one. Plasmonic wire grating is the most relevant example to what we are doing. Okay, let's just share you plasmonic wire grating. Okay, so something is coming up, loading up. So, yeah.
Hello, sir. Sir, during computation, I have faced an
Yeah.
occur.
What
Error.
error?
Okay, sir. Undefined material property n required by wave
Yeah.
equation.
So can you
Metric
check
1.
if you have assigned air material in the top domain? Just check whether you
Yes, sir.
applied air to the top domain, silica glass in the bottom domain, and air gold to this central domain.
Okay, sir.
Okay, so any one of you guys getting something?
I'm getting an error. Can I share my screen?
What is the error that you're getting?
So it shows duplicate parameter by variable or variable name, three variables, COMP1, EWFD,
Okay, yeah, yeah. Can you show your
S2X.
screen? Yeah, okay, that's good. Anyone getting the results or
Yes, sir.
Roshan?
Yes,
Yes,
sir,
sir.
getting.
Sir,
Oh,
I'm
you
not
are
getting, but it's not similar as yours.
okay, no problem.
It is not like that.
No problem. We'll look into it.
I think these are.
Sir, in my geometry, it seems both the top and bottom not able to change the top one to the air now, so I get a different result.
No problem. So, one thing I don't know, I can see like very squeezed up. So go to the diffraction order one in port one. Okay, go to port 2. Yeah, you change the port name to port 3 because 2 has been used by diffraction order. Okay, and then go to
Okay.
diffraction order
And
1.
then
It should be
this is
4.
me.
Yeah. Now you try to run the model.
Okay.
Okay, so it should be running now. You can go to the progress bar and see if this kind of next variable is coming or not.
Yeah.
It should be working. That's fine. How about others? Kavita, you had a question, I guess.
Yes, sir. I'm not getting the result as yours. Okay.
No problem. You can share
Still.
your screen. Don't worry. Now, don't. If you get some result, it's fine. You'll get to know because sometimes you might not get the exact results because of some variation. So what?
No, I don't understand what is coming on the
Yeah,
screen
don't
at
worry.
all.
So let me share my screen. Okay.
Okay.
To know, so that's why it's very important to do it step by step. Okay, so now ideally what we should have done, we should have only model air first, all the domains air. Second step would have been to model air and silica domain and then see the propagation. Third should have been to add gold material and then see it is you're able to, because of the air, so the gold material, what are the change in the refractive index. But because of less time, we did it completely together. Now you try to plot EWFD dot EX. Okay, try to plot EX in surface 1, EWFD dot norm E. Instead of that, you write to plot EWFD dot EX, and then try to plot this player. Okay, you need using this dynamic data extension and repeat as forever. And then you can see like how is the propagation happening. So this kind of propagation it should happen. So this makes sense because your again your electromagnetic wave is polarized in x direction, so the high and low is there, and then there is interaction between this conducting material, right, and then it goes to the silica domain, right. So this kind of motion should happen, should be very much similar to this. So I'll wait for a few moments for you guys to explore this, and if you are getting this.
So you change the expression by EX then?
Yeah, capital E, small x, go to
Yeah,
animation.
yeah.
First,
I'm
dynamic
not
data
getting your,
extension. Sorry,
yeah, I'm not getting your voice now, sir. Can you tell
can
me
you hear
again?
me?
Yeah,
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 just go
now.
to animation player.
Yeah.
In that, you go to sequence type as dynamic data extension.
Showing error that an animation must contain at least 2 frames.
No problem. Just go to close that and then go to sequence type and change it to dynamic data extension.
Yes, sir.
Okay, then
Yes,
you
sir.
repeat as
Yeah.
forever.
Yeah. Done.
Okay, and then just play.
Sir, the color is different. Like I'm getting blue color only, not
Yeah,
this
can you show your
color
screen?
getting. Yeah, one second. So I'm not able to share screen.
Okay,
Sharing, but
no
it's
problem.
loading, I
Yeah.
think.
But are you able to see something like propagating?
You, before you were getting
Or
that same result, I'm getting that color changed to that yellow color. Some that I'm not getting. That.
but once you play this animation, are you see the propagation or standing waves?
Mm,
Yeah. Standing waves means these things will not propagate. Like it will be
not
constant.
not propagating. I
It's
missed
not
some
propagating?
last part. Yes, sir. Before it, the result what you got, I got same only.
Okay, okay. But yeah, if you share the screen, then I can see.
Yeah, sir. I'm trying this.
But in my case also there is, I'm confused with whether it's propagating or standing.
Yeah, can you share your screen, please? Okay.
Yes, sir.
So have you plot, what is the surface plot? Can you go?
Surface.
Surface 1. EX. Now what is surface 2?
I think that I have
Just
delete.
right click on
Just
surface 2 and
mistake.
delete it. Otherwise, it
Yes,
will
sir.
overlap
Deleting.
both of the results. It's very difficult otherwise.
Oh, okay,
Now
okay.
you go to
This
animation 1
one.
and then play. I already have animation 1. Just don't add one more animation. If you add it, it's fine.
Okay.
No problem.
Yes,
Yeah,
sir.
now play.
Where should I? Like
Graphics.
this.
No, no. In the graphics pane, second left button. That one.
Okay.
Yeah,
Yes.
so it's not a standing wave, right? So that's what we want. So it should be like energy should be
Okay.
propagating from top to bottom because port 1 is source, port 2 is the listener port, and then yeah. So one
Okay.
way of interpreting the result is that because the conductor, it's you can see there's some reflections as well as energy being
Mm.
propagating. So because conductor is eventually electrical field would be zero inside this, right? So it will trying to reflect it. It's like a PEC domain, so trying to reflect it. So that's how it is happening. So it's kind of reflect and energy is propagating from the sides. Okay, even if you plot this
Okay.
um, power, you will see that it is actually going to the sideways. Okay. That's good. So how about others? Are you getting
Thank you.
these results?
My screen.
Yeah. Yeah, please. Can you share your screen? Okay. Oh, wow. So this is standing waves. This is what is a standing wave. That's why it's important to do the animation because there is no propagation. So means can you click cancel? Can you press stop? Yeah, and then go to
Yes,
this
sir.
port 1. Yeah, so here port on excitation. This all looks good. Go to port 2. So here given in the top right should be in the bottom. Assignment of the port should be on the bottom, not on the top. Boundary.
This one.
Yeah. So this is the port 1, right? You already assigned port 1 to the top boundary. Port 2 should be assigned to the bottom boundary.
Okay.
Right. So just change that and then run the model again. Then you should be able to see it. Okay.
Yes, sir.
That's good. So let me share my screen again and try to see the scattering parameters. Okay. So if you go to reflection, transmission, and absorption, you will see a lot of plots. You can see those, you can interpret those plots, but it's always good to create a new plot. So to create the new plot, just right click on the results, 1D plot group. Okay, in the 1D plot group, right click on it, below to make a global plot. Okay, and then just mention that ABS EWFD dot S31 because third is the second for the second port. This is the transmittance, and then as you know, absolute of EWFD dot S11 is for the reflection. That is for the reflection. Then you click on
Sir,
So
how
in
did you
the
get plot to?
plot 2. Sorry,
Sir, how did
so
you get
share
this
this.
1D plot?
Just right click on the study, right click on the result node, and click on 1D plot group. Okay.
Hello, sir.
Yeah.
Sir, I have got another type of during computation.
Sorry.
Can I share my screen, sir?
Yeah.
Okay, sir. Hello, sir.
Mm-hmm. Yeah. So what is the question?
Sir, I have got another type of speaker.
Okay. So you're using a different wavelength, right? So we were using 600 nanometers. You're using another wavelength. So that's not a problem. Not here, but have you done the parametric sweep, right? So in the parameter value, 0.4 is written, right?
Okay, sir.
Yeah. If you so based on the wavelength in the 2D plot group settings, not that wherever you're doing, but here below the data set, right? In the middle section. Yeah, this 0.4 written, right? Over there, you need to change. So if you see my screen, okay. So here, for example, 0.4 is written. So you have not done parametric sweep.
No.
Study one instead of study one solution one. Click
Okay,
on
sir.
study one solution one. Okay, there is no parametric sweep. So you have not done parametric sweep. Have you done parametric sweep?
Sir,
Now, if you go to your study node, yeah, first is this, yeah. If mesh, don't use user control mesh, use physics control mesh. Okay, here add physics control mesh, and you forgot to add the parametric sweep. Okay, so you can see my screen and you can add a parametric sweep. Okay, so this is how you need to add. Yeah,
how can
sorry.
I add? How can I add, sir?
Yeah, just right. So if you right click on study one, click on parametric sweep. Okay.
Okay, sir.
Yeah, and then you can just add this parameter and copy paste this in parameter value list. I'll share that. Okay, it's meant, and then you can compute your model.
Okay, sir.
Okay, so I hope you have added this 1D plot group 4 with global plot in the inside. So it is S31 because S3 is represented by the second port and port 1 is 1. So your reflectance is by absolute of S11 and transmittance is by S31. Now if you plot it, it will plot only for a single wavelength. So you need to do it for all the wavelengths. So in that case, you can actually go in the data set, use the study one parametric solution over here and then click on plot. So here you will see the results in the dot. Okay, so you can actually convert this into outer solutions. I think then it should give you in the continuous line segment, continuous line. Yeah, so here you can see. So it's a continuous line segment. This is for the transmittance. The blue line is for transmittance. The green line is for the reflectance. Okay. So ideally you need to do for a very small shift in wavelengths. Right now we have a huge wavelength shift, so that's why we have a significant shift from very high transmittance to low transmittance like this, right? But if a very small shift of wavelengths like 5 nanometers, 2 nanometers, then you'll have very smooth transitions like what you saw earlier, right? Over here in that blog, if you remember. So if you see in the blog, right, so these kind of transmissions you can actually be able to see. Okay. So anyone getting this kind of curves of trans?
Sir, I'm getting one error. Not error exactly. So when I try to add this 1D plot group, global one. I don't see anything that is there in this version. Can I share my screen and
Yeah.
check? Uh, hmm. In this
Sir,
global
one
one,
question.
Yeah.
Can you add
Yeah.
this
I will just
expressions?
answer your question. Let me just go through Ayushi's model. Yeah. Sorry, Ayushi. Yeah, yeah. No, no. What you have done is I don't know. So just right click on the results again. Yeah, 1D plot
yeah.
group.
Here I
Yeah,
changed
and once
number.
you right click, no, no, don't change here.
Okay.
Right click on 1D plot group 3 and click on global plot.
This one.
Yeah,
Okay.
and then you can
Oh,
mention, yeah, and then you can mention this thing, okay, that I've mentioned in the chat box, okay.
But I'm not getting the graph.
Yeah, yeah, you can share your screen. Yeah, so here you're getting for single values, right? That's why you change the data set from parent to outer solution. This one, just click on from parent and change it to study on parameter one and go down. No, no, don't click on plot. Yeah, so go down here. You can actually plot it for dots. Actually, you change from axis source data from lambda naught to outer source, outer solutions.
oh, okay.
Okay, and then click on plot. Then you will plot it in a single line. Okay.
So this is
Yeah.
the question. Why are we not getting the plot for all the lambda? We're getting only for 4.
No, you're getting here, right? If you see the screen, you're getting from 400 nanometers to 700 nanometers, right?
What's it?
Yeah, let me share my screen. Yeah, so
400
here
to
you can see
700.
this is, can you see my screen?
Yeah, yeah.
So this is from 400 nanometers to 700 nanometers. For all the wavelengths, I'm getting a transmittance.
What I asked, sir. Like I asked, like why the plot is not showing all the way. Sorry, all the transparents and reflect in the same graph. Like in this way, it has to show right for all the lambda. It has to show right for 0.4, for 0.6, for 0.
No, in the y-axis is the wavelength. So this were 400 nanometers.
Okay, okay, yeah, got it, got it. No, no, I was looking at
Yeah,
the
got it,
legends.
right?
That's nothing.
Yeah, 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 correct. No, no, this is in nanometers, for example. So
Got
yeah,
it.
I mean, this is legend is kind of a little bit misunderstood actually. This is actually transmittance, and this is reflectance. Actually,
Yeah, yeah,
this,
got it.
yeah, yeah. You can make it manual.
Sir, excuse me, sir.
Yeah,
Sir, I'm Jansi. Sir, why the graph is fluctuating? Is there any significance for
yeah.
this
That means
particular?
that if you have lower, means the transmittance is becoming lower at around 580 nanometers, and reflectance increasing. But this is not the actual what do you say the actual notification or actual behavior, because if you see, if you go to coloring and style and make marker as asterisks in data points, you will see that this is the data point that you are solving for. Okay, and between that you don't know what is happening. It's just interpolation is happening right now. Okay, so ideally you need to have a very small step of frequency shift or wavelength shift. So you nicely get some nice curves. You will get multiple peaks. You will get.
Okay,
Okay.
okay, sir. Yes.
Yeah, and lower peaks means the lower transmission. So it's means it's deflecting more. Is the green is more, means more reflection is there at 580 nanometers. So it actually works like a filter, for example. Okay.
Yeah, yeah.
So why I'm getting the transmission
Sorry.
as so why I'm getting the transmission as 0? It's only a constant line there. It's not like yours.
Yeah, I saw that. I don't know because some material properties is changed. Perhaps have we used the same Johnson and Christie material properties?
Yes, sir. It was Johnson there, though I selected that.
Okay, so perhaps because of that material properties, it could be changed. Okay, but don't worry, the process is the same thing. So if you apply the same process, you will get it. For example, in this example also, it's a library example, plasmonic wire grating. You can see the same approach has been mentioned. Okay, air, dielectric material, and port one in the top, port two in the top bottom. Okay, and then the study, they they don't do any parametric sweep here. In the step two also, they do it over here in the bottom. So this is for angle of inclination they have done. Okay, yeah.
So does it have any coincidence with the diffraction order I have added?
Diffraction order you have not added, right? Or have you added?
I have done this out of plane and
Okay.
like this only.
So you are using COMSOL version which one?
5.3.
5.3. Okay, okay. Yeah, could be because of that as well. I don't know. Because orthogonal polarization, if you want, you can also see how much is the contribution of orthogonal polarization. Okay, I don't want to do it here. Maybe I can duplicate it and see how much is that contribution of that one. Right now, you have not added any higher order diffraction, right?
Yes, sir. Currently, right now.
Okay, okay. Yeah, it's almost zero, so it is not happening anything. So let me put with this one. Yeah, this is also almost zero, so nothing is there in port this one. So yeah, not much difference is there.
Should I keep the theta value as 90? Will it make any
No,
effect?
no, no. That is different. That is mode phase. So angle of incidence is zero. Mode phase is zero. So that how about default it should be zero only. How about other? Are you guys getting any results like this one similar to this one?
Sir, in the legends, it doesn't show which one is what is what. Like, what is the transmittance and what is the reflectance curve. So how do I understand this?
Um,
Like, in your graph, blue is coming on top, and that I think
yeah,
is
I just
not
changed
right.
it. Actually, you can share your screen.
Uh, yeah, okay, nothing is
Yeah, yeah, yeah.
mentioned.
So here in the description, you just write it as capital T uh, or you go down, go into the
Hmm.
legends.
Here,
No, no, no. In the bottom, bottom of the settings
bottom.
pane, legend. No, no, no. In the middle,
Okay,
below,
here.
below, below. Legends. Open
Mhm.
the legends.
Oh, okay.
Yeah.
Sorry. Yeah.
Go instead of automatic, make it manual, and then write first capital T and then capital R. Remove that complete part lambda not equal to 4 equal to zero point
So,
0.5. Just write capital T.
oh, okay, okay. And oh,
Yeah.
and how do I understand? Like, because I have no idea. Um, like I have no idea what is what. Like,
Yeah.
how
So
do I
for example,
understand?
the blue curve signifies the transmittance. Okay. So what you can do, you can
How?
remove the sorry,
How?
blue curve
How?
signifies the transmittance.
How to understand this? I have no idea.
Yeah, this is what I'm saying. So blue curve that you're saying is significant transmittance, means how much energy is being transmitted. Okay, the green curve signifies reflectance. So ideally, when you see that when the transmittance is very high, the reflection should go
Hmm.
down, and then when the reflection is very high, transmittance should go down. But I see a opposite trend in your case, right? So I don't know. Can you show this? What is the port two? What is the in the port 2, what is the port number of that port 2? It's port number 3 only, right? Okay.
Hmm.
Okay, and port 1, what is it?
Okay, I'm fine.
Same only.
Mhm.
Okay, this is almost the same dimension as well. So you're working with nanometer range, right? If you go to geometry,
Mhm.
nanometer range only, right? Yeah. So here silica glass, yeah, okay, gold Johnson you have used, so not much change should happen with that. Yeah. But yeah, you can see this plasmonic wire gritting example as well. So it's
Sure.
same thing that it goes through. I'll just share my screen, and it is the same process you need to follow. It has the step by step process to make the whole model. Okay, so for practice purpose, I suggest you to go through this example. This is plasmonic wire gritting. I already shared it to you guys. It's using RF module, but that doesn't make any difference. So you can use RF module as well. We have this wave optics module inside this one. So if you go to file application library, you go and choose this plasmonic wire gritting. Same example. Just search over here in the top if you are not getting. Okay, and hopefully I can show you. So if you, along with this model, it also has a PDF document. Okay, so this is a PDF document. So they have done with, say, a different angle of inclination, as you see. We have done with a sweep of wavelength. Okay. So it has the physics part. We'll discuss the physics part first. My system is a little bit slow now. Yeah, so it talks about the physics part first, and then it goes to discuss about the diffraction orders. Yeah, my system is hang. Yeah, so here is the result section. Okay, and then it has step by step process to make the whole model. So here you can see it's for higher order terms. So this is for higher diffraction orders. Okay, and then it has this yeah, the step by step process to make the whole model. Okay, the one that we have done today, same steps is there whole way. So if you want to practice, you can also use this model to practice. What ideally you should see that when the transmitter is going low, means it's, you can assume it's a two-port network. So transmitter is going low means energy is getting absorbed, either absorbed or reflected. Okay, so absorption is getting increased. The transmitter is very high means around 1 means it's almost 98% energy is being transferred at this particular wavelength.
So, when you were trying to modify the legends, you said that okay, put T instead of that and R instead of that. So how do we understand like blue is for transmittance
No, no,
only and green is for reflectance only?
this is there, right? So S
Oh, okay,
parameter is
okay,
there,
okay.
right? So this is for
Expression.
transmittance,
Okay,
this is for
parameter. Right.
reflectance.
Okay,
Yeah.
okay. Got it. Thanks.
Hmm.
Sorry.
Yeah.
Hello, sir.
Yeah.
Sir, actually, I have to work on 3D simulation this plasmonic nanoparticles. Basically, I
Okay.
have to do this me scattering. So, can you suggest any example which I can work out? And
Yeah, yeah. So we have this plasmonic nano scatterer. So it actually talks about the scattering. So scattering coefficient. It talk about. Okay. So
basically, I want to calculate electric field enhancement for different shapes.
yeah. I
To
understand. So
calculate.
yeah. So that's what we had planned for tomorrow actually. So I can show
Oh.
you how to find this electric field enhancement because of the scattering.
Hmm.
Okay. So tomorrow I can show you. Today, if you want
Meanwhile,
to, yeah,
can you share that
yeah.
tutorial?
Example, I will share you.
Oh.
Okay.
Sir,
Yeah.
if you have time, just I have one more question.
Mm-hmm. Yeah, just hold on.
Uh,
I'm just sharing this example model for your, actually I will share you this one. Okay. Yeah.
so in the result section of what we did now,
Yeah.
so the solver automatically created a 1D plot group reflectance, transparent, and absorptions, right?
Sorry, can you come again?
No, in the result section,
Hmm.
the software itself created the only plot group for reflectance, transmittance, and absorption.
Yes.
So
Yes.
there, I can see multiple expressions. So one
Okay.
refers to OR order, which means reflection order 0, reflection order orthogonal polarization, reflection total. So what does these means?
This is the same thing what we have done. So this is for zeroth order. If you have any polarization or orthogonal polarization added, extra ports added, so it will give you for the each of the orders. For example, you have three orders extra. Have you added diffraction orders? It will give you
Okay.
for each of them. Okay, and then the total one it will give. So T total, R total, and A total. Addition of all of them.
Okay.
Okay.
So can you explain this with an example? For example, if I have a DBR, so the zeroth order reflection means like a multi-layer structure like DBR.
Uh-huh.
The zeroth order reflection means the reflection at the first interface.
Yeah, I can share you one blog which talks about this diffraction. I think it also will help Roshan, who's asking about the diffraction angle. So this is a very nice blog, periodic.
Okay.
Uh, Periodic. What? Nice blog um, written by Walter. Yeah. So here it talks about all this higher. So if you are learning for this, you can see this. These are the higher order mode. This is zeroth order,
Okay.
+1, -1, -2, and reflection modes and transmission, which actually has all this one over here, right? So you can go through this, and if you still have doubts, we can discuss tomorrow. Okay.
Oh,
So just
oh,
go to this
thank you.
blog. It talks about detail
Yeah,
about
sure,
this
sure.
diffraction orders. Okay.
Oh,
So direction also you can actually get it if you want. You can just make an angle of that with respect to the normal direction, and you will get should be able to get the direction as well. But that direction you have of how it is propagating, it should be possible, I guess. Yeah,
okay, okay. Got it, sir. Thank you.
looks good. So that's it from today. Tomorrow we'll talk about scattering, how to find this scattering parameters. And also how to find effective effective enhancement, and let it see. Okay.
Excuse me, sir. One small doubt.
Yeah.
Actually, I was asking the prism and the sphere. You told to make two components. Should I start with 2D or 3D?
Yeah, 2D, always you start with 2D. Yeah, it's best to start with 2D and only model the interface. Don't model the whole prism, because modeling the convergence from the prism doesn't make sense, right? So only the interface where the things are happening, only those places you need to
Yeah,
model.
the cross section, you mean?
Mm.
Yeah.
Yeah, even in the cross section, they don't model the whole thing, like whole prism and all those things. Only at
Mm.
the interface, how it interacts with the other gold material and all those things. So at the interface, you need to model. You need to be very smart when you're modeling with simulation.
Sir,
Yeah.
then how to handle the tips that will be more difficult, right?
Sorry.
The example that you was telling in the prism. So you were telling only the interface. So in case of a
Yeah, you
prism,
start with
there.
the interface. Yeah, first see with the interface what you're modeling, does it make sense or not. Okay, then you start to make it little bit large and so on. Right? If you start in the starting only, you make very big geometry, then it will keep on the system will keep on hanging, because it will take a lot of memory to converge the model. Okay, so you can start with simple, just the interface, and then you can keep on making the geometry bigger. And that's how is the best practice method to model any complex geometry. Okay.
Oh, it could be that I can assume two spheres, and one of the sphere I could make some deformation, and then.
Yeah, that is also possible. Yeah, that is also possible. Mm.
Sir, we designed something, but how can we verify it's correct or wrong?
Means one way is to do the experimentation. to verify. Otherwise, simulation is there's no way to verify, right? Another way is to do, if your model is correct or not, is to replicate a model from a journal paper. See if you're getting the same transmittance and reflectance. Once that is making sense, then you keep it, change the geometry based on your requirement. Okay, so either you do the experiment or you replicate the same paper, same model which is done in a journal paper
So
to validate.
fabrication it's very tough for this
Correct,
nanostructures.
correct. Yeah. So other thing is to validate a model which is presented in a journal paper. See if you're getting the same results with the same boundary conditions, and then you keep on changing your geometry slowly to what is your requirement.
Okay.
Because this is a simulation tool, so how it can actually tell you with the real world, right? It will do whatever you want to do, right? So it's not the job of COMSOL to tell whether it is practical or not. You have to make COMSOL to work it as much as possible to the practical scenario. Okay, so every software means any simulation tool has its own limitation, and yeah, that's good. So thanks for discussion today. So let us meet again tomorrow to take it forward. Thank you.